So we are looking at transformation, object reflection, rotation, translation, enlargement, image, then vector, magnitude, and scalars. So it starts with vector and transformations, but stress is more on transformation. Vectors is not that large in IGCSE. Or let's just do the first topic. This explains translation. That's reflection. See the first image. I'm hiding those names. What is it? What do you think it is? The first image.
It's like a mirror, so it's a reflection.
It's a reflection. The second one.
Rotation.
That's a rotation. And the third one.
Transformation. No, translation.
Third is translation. Yes. And the last one.
It gets smaller, so enlargement, right?
That's enlargement. Yes. So simple plane transformations, we have reflection, rotation, and translation, enlargement. Another example of reflection, rotation, translation is just straight plane movement in any direction, and then enlargement. So reflection, we'll be studying three different type of reflections. One is in horizontal line, one is in vertical line, and the third one is at line at an angle. So if you see the first image, that is reflection in the vertical line. So it just acts as a mirror. Whatever the distance is to left of it will be to right of it, and that's how we can get the image for an object. The second example is a horizontal line. Properties of reflection is the distance is equal, the angles are same in opposite direction, they are bisectors. If you connect A and A dash, B and B dash, you can draw the line bisector. That would be the mirror line. Angles are same on both sides. Okay, question would appear like this. Let's draw the reflection of the given object. So what I need to see is that it is one box above, so it would be one box below on this point. Then this is two boxes above, so two boxes below the mirror line. C is three boxes away, so C would be three boxes away on the other side. So when we get this, we just use a ruler and pencil to draw the image of the given object under the reflection. A shape and its reflection are shown on the grid. Draw the mirror line. So if the shape and object and image are already there, I just need to see where exactly is the midpoint. So I can see this is 1, 2, 3 total boxes. So 1.5 on either side, or I just find the midpoint of any two reference points. For example, we are looking at 2 and 8, 0 and 8. So midpoint on 0 and 8 will be 4. Any two reference points, any two corresponding points. Second part says what is the equation of the mirror line. So it passes through x is equals to 4. Shape A is the object. Reflect shape A in the y-axis, label the image B. So we are reflecting it in y-axis. We just identified this is y-axis. So it is 1 unit to right of it, 1 unit to left. And then the other point is 2 boxes. This is 2 boxes. Now I don't need to count all the boxes. I can just relate with this line that this is 2 boxes back. So I can make this 2 boxes back, rather counting that this is 3 boxes away. and then this is vertical line. So you can make that judgment and draw the shape. B part says reflect shape A and shape B in the x-axis. Label images A dash and B dash. So when I'm reflecting these two in x-axis, this is how A would look like as A dash, and B would look like this. This is a practice exercise. I'll share this with you. You have this book, right?
I have this book.
Okay. Just go through few mixed questions, at least for reflection. And then, inshallah, if there is any problem after discussing that, we'll start rotation tomorrow.
Okay.
Anything you would like to ask?
No.
Take care.
Thank you.
Okay. Vectors and transformation. We discussed few of the examples of reflection, and this was the practice exercise. Did you get time to practice any? Can you hear me? Hello.
Hello? I think my microphone was glitching for a second. I was
Did
all
you get time to practice any?
Oh yeah, I did. They were all pretty easy.
Okay. Question one, two. Okay. One says that draw the images. And what about this line of reflection?
Yep.
Draw and give the equation. Drawing is easy and equation as well. X is equals to 2. Vertical line is always x equals something. Horizontal line is always y equals something. And this is y equals 0. Copy the axis and shape onto a squared paper. Reflect polygon A, B, C, D, E in y-axis. Give the coordinates of point B after reflection. So
I understood up to B for that question. I could do it and then give the thing, but I didn't know what invariant meant.
okay. So this is reflection, and point B would be x minus 1, y3. Invariant is that stays where it is. So that was in this case point A. The coordinates are not changing. That is 0, 2,
Oh,
before
see.
and after.
Okay.
Whatever the case is, reflection, a rotation, enlargement, whatever the case is, invariant point is the one which is not changing.
Okay.
Copy the x's and the shape onto a squared paper. Reflect the shape in the line x is equals to 1. So this is x is equals to 1. I can only see that this is 3 boxes to left of the reflection line. So 3 boxes to right. And then this is 1, 2, 3, 4. And to be precise, that was not 3, that was 2.5. This is the one at the top, the one at the bottom, and this is the reflection. So that was line equals 1. Reflect. Now this is the new shape P dash, Q dash, R dash, S dash reflect this in line y is equals to 2. So y is equals to 2 is this line, and when we reflect it here, the point at the top comes here, and this is how the image is going to look like. And all these are now going to be double dash. This is P double dash. Question number 5 says copy the axis and diagram onto a squared paper. Draw the image of D, E, F when reflected in y-axis. So it is already touching the y-axis. So just on the other side, F point would be reflected. And this is F dash, D dash, and E dash. Give the coordinates of the point F before and after reflection. So before reflection is -2, 3, and after reflection is 2, 3. Reflect D, E, F in the line y is equals to 1. So y is equals to 1 is this line. So E is 1 unit above this line, so 1 unit below. F is 2 units above this line, so 2 units below. D is again 2 units above, so 2 units below. This is going to be F double dash, that's E double dash, and the one at the bottom is D double dash. Next exercise is rotation. In our syllabus, we'll be having 90 degrees clockwise rotation or 90 degrees anti-clockwise rotation or 180-degree rotation. So first of all, if we are discussing 90-degree clockwise rotation about the given center, in this case, the object and image and center are already given. So if I have this object placed right there and I have to rotate it 90 degrees clockwise about this given center. So if this is my first point of focus, I'll see that it is 4 boxes away. And when this green line is going to rotate 90 degrees, it will become vertical and 4 boxes away. That is my first point. Same way, we can select the second point. Let's say this is my second point from the center. So when it will move 90 degree, this is where it comes, and we can see how much is the distance by using compass. And other way we can do this is, if you're not sure, I can just see that when I'm talking about this point, it is 4 boxes to left and 3 boxes above that position. Now moving the horizontal and vertical lines are very easy. So when this horizontal line is going to turn around 90 degrees, this is going to be perfect vertical because it was horizontal before, and this is 4 units, this is again 4 units. Then there was a 3 box line to right of it. So 3 box line to right of it comes right there. So once we have these two, they are still enough to complete the shape, because now I know there are 2 boxes to right of that, so 2 boxes to right of that. And then again 2 boxes, 2 boxes, so we can just judge and complete the shape. Other method is using a tracing paper. You just place the tracing paper and then place the needle. We just draw it on the tracing paper, then place the needle where the center is and rotate the tracing paper by 90 degrees, so you'll get the new shape. So a rotation through 180 degrees, half turn. Rotation through 90 degree is a quarter turn. Anti-clockwise rotation is positive and clockwise rotation is negative. A point and its image are equidistant from the center of rotation. Obviously, if it is just rotating, so if I just name it A and A dash, the distance is going to be equal. Each point of an object moves along the arc of rotation. All the circles are concentric. Only the center of the rotation is invariant. Every other point is moving. The object and the image are congruent after rotation. That means the size stays same, the angle stays same. The perpendicular bisector of the line joining the point and its image passes through the center of the rotation. Let me explain this. For example, we have these two triangles, number one, and after rotating it 90 degrees, it looks like this, 90-degree clockwise. So I would just say that A and A dash correspond to each other. So I'll draw perpendicular bisector of A dash and then other two corresponding points, let's say these two, and perpendicular bisector of these two is this one. So where they intersect, that is the center of rotation, this line. The perpendicular
So
bisector of
the
line.
yeah. So the intersect of like the distance between both points. So we would draw the lines exactly where it would
First is A dash. We
yeah,
draw the perpendicular bisector of A dash. That is any one corresponding pair.
okay.
Then we draw the line for B dash. That is any other corresponding pair. Where these two perpendicular bisectors would intersect, that is the center of rotation. That means this is the angle of rotation.
Okay, that has been done. But where how do we draw the lines? So we know it's we connect the B and the B dash and the A and the A dash, but you know we draw lines after that, like on top.
You actually don't need to draw the line. We just need to place the compass on the point. For example, if I just say this is A, B, C, so this would be A dash, B dash, and C dash. So when I have to draw perpendicular bisector of A and A dash, I'll place the needle at A, open the arc more than half, and on both sides. Then needle at A dash, and then this. So this is the perpendicular bisector of
Yeah.
A. You don't have to draw this line. If you draw, don't draw, makes no difference.
And then
Then,
from the one that we did, yeah, the
yeah,
second one.
second one, CC dash, any other pair. So CC dash, we open the arc more than half and we just make those intersections, and where they would intersect, this is the center of rotation.
And then we measure
That
the
means
angle.
this, yeah, this is the angle of rotation.
So we
This is
check it from the two connecting points.
yeah.
We'd connect them to the point. Okay.
These are just freehand drawings. Otherwise,
Yeah.
it would be between 90-degree clockwise, anti-clockwise, or 180. 180 is going to be pretty much simple because that would be straight lines. If this is it, and let's say this is the center, so obviously when I connect this, it is going to rotate 180 degree, make a straight line and equal distance on the other side. So this is A dash. Now rotating this point is against stretching out the line on the other side in equal distance. So if that's B, this is going to be B dash. The third one, connecting these two and stretching out the line. So this is C dash, and this is the triangle which is being one rotated 180 degrees about this given center. So that was one thing, that object was given, center was given, and we had to find the image. So if we were having object and image, you can see that we can judge easily that this is not 90, this is 180, because you can see A, B, C, A dash, B dash, C dash swap. C was below, now C dash is above. B was above, B dash is now below. So you just connect two corresponding points wherever they intersect is the center of rotation. This is the center of rotation for 180 degrees.
So for 180 degrees, we connect two points in a straight line,
Yeah.
and then
And then
the point that they intersect is their point of rotation.
yes, for
Okay.
90 degrees, we need to draw the perpendicular bisectors.
Okay.
Or any other angle would also give you the center by drawing perpendicular bisector. Only 180 is the one for straight lines. The line segment of its image are equal in length because it is just the rotation. If I'm connecting it with B and rotating it through any angle, the length is going to be same. P dash, P double dash, anywhere. The length is going to be same. To describe rotation, you need to give whenever the question would be describe the rotation completely or transformation completely, we're going to say that it is a rotation about this center and angle of rotation is this and the direction is clockwise or anti-clockwise. We don't need to say that in case of 180. So in case of 270, I can say that these two are rotation of 90-degree clockwise about the center x comma y. Or I can say for the same triangle that this is 270 degrees anti-clockwise about the center x comma y.
So I don't really understand. So we would just talk about it from the center and what degrees it was.
You didn't get this last point 90 or 270?
I know that those are, yeah, I know they're angles that from the 360, but
Let me show you.
okay.
For example, this is my center of rotation, which is x2, y3. And this was my object. And this is the one after after rotation. A is mapped onto B. So I can say B are just A onto B. A is mapped onto B. So I can say it is a rotation of 90 degrees clockwise about the center 2 comma 3. So we would know that A is being rotated 90 degrees about the center 2 comma 3 to get B. Or I can
So the
just,
information we need to give is the angle of rotation and the coordinates for the center.
we need to give these three things, that it is rotation, how much, direction, and center.
Okay.
And we can say it is a rotation of 270 degrees anti-clockwise. So if we just rotate it 270-degree anti-clockwise, it's going to land again on B. And why is this so? We would always prefer the first one, but if the question says B is mapped onto A by a clockwise rotation, so what would you say? B onto A and clockwise, what will be the angle?
It's still so from 270.
Yes. And if I just don't bound you, I say B is rotated on A, what would you say?
That would be still 90.
Yeah. Now you can say anything. When I just say B onto A, so you can say 90 anti-clockwise about 2 comma 3, or you could say 270 clockwise about 2 comma 3.
So it can be either one.
Yeah.
Okay.
So you can use thin paper or tracing paper to help you do rotations, trace the image and label the vertices just as we discussed. Place the tracing over the object. Use the point of pair of compass to pen to hold the paper at point of rotation. Turn the paper through the given turn, like 90 degree or 270 or 180, and we can draw it on the new position. Rotate the shape 90-degree clockwise about the origin. So what we'll do is place a tracing paper like this, and I'm going to draw it very neatly on the tracing paper. And then the question says about the origin. So about the origin, I'll place my needle here. Now I'm going to rotate the pressing paper. This page, this side is horizontal, so I'm going to rotate it 90 degree and bring it on this side. So definitely I can't rotate the screen right now. So let's say the page gets turned around, and this is something on the tracing paper. So we can
But
just have,
how would we make sure that the paper doesn't move? Like,
yeah,
how would
you have your needle all here all the way, all the time,
Oh, okay.
at the point of rotation, at the center of rotation. So that point is not moving. The page is only rotating 90 degrees clockwise. So you'll have this image shifted, and we can then just place the dots, which would leave slight marks, or not necessarily. You can just see the first coordinate and then draw the required rectangle.
So for the exam, we would need tracing paper.
That's one method, yes.
Okay.
We'll practice few questions, and maybe you can do that without tracing paper as well. That is a tool which is allowed. You can always use it. So 90 degrees about origin is that one in purple, and in red is about A. Now we'll be drawing these definitely without using tracing papers, as our mode of study is online. I'll show you how. Copy the diagram in parts A to C. Draw the images of the given triangle under the rotation described. Center of rotation is 0, comma 0, and angle of rotation is 90 degrees anti-clockwise. Okay. Center of rotation is 0, comma 0. Angle of rotation is 90 and anti-clockwise. So a rough idea is that this will move towards this side. Now we are doing this without using tracing paper. I'm dealing with all 3 points individually. Luckily, we don't have to deal with A because that is already on the center of rotation. That's an invariant point. So this is C. Now I'm imagining a fixed rod welded to C. So when I rotate this 90 degree anti-clockwise, the rod will come at this position, telling me that C was here and C dash is going to be at this point. Now I'm going to remove the rod, use the same rod for B. So if it is connected at B, now the only problem is when I'm going to rotate this rod, the length is going to stay the same, but I should know that where exactly is it going to be, like where will it make 90 degree. So that is going to be a long process if we use protector, or we practice so much that we are familiar with the boxes where it makes 90 degrees. So one easy way would be that rotating this B, I'm using this L shape rod to rotate that B. Now this blue line is solid iron welded to B. Now when you rotate this iron by 90 degrees, would you agree that this horizontal line from 0 to 2 will look like this? And the other part was to left of it would appear on this point,
Yeah.
and this will be B dash. And I can just count without drawing it. I can see that this is 1, 2, 1, 2, 3. That is 2, 3, 2, 3. So I just know 2, 3. So I'm getting my points B, C, and A. This triangle has been rotated 90 degrees anti-clockwise about the origin. Same with the other. Center is 3, 1 already marked with the red cross. Angle of rotation is 180. It is to left of it, so A is coming to right of it after 180-degree rotation. Let me change the color to avoid any mixing with the center. So A is to left of it, 2 boxes. It will go to right of it, 2 boxes. This is A dash. Same for B. B comes to left hand side, that's B dash. Now when we are dealing with C, consider that we've connected C, and you can use straight edge and line and extend the line and make sure the length is equal on both sides. So this is point C. A dash, B dash, C dash is B about the given center. Any confusion?
No.
C part again 180. So we can see this point. Luckily, on both sides, the length is equal. So this point at the top comes here, point at the bottom goes there. That's a switch. So we connect these, extend the line. This is my third point. So 180-degree rotation about the given center is this. Clear?
Yeah.
Let me use a grid to show you a few more examples. Okay. I'm just using this grid. The question might be asking something else to go for rotation. And we are rotating triangle A onto C 90 degrees anti-clockwise about 0, comma 0. Is the question clear? So the center is 0, comma 0. I'm going to rotate triangle A by 90 degrees anti-clockwise. So we look at those points individually. If this is A, this is 2, 1. So when it rotates 90-degree anti-clockwise, this is 2, 1. This is where it lands. Second point, this one. This is 3, 1. 3, 1. So 90 degrees anti-clockwise is 3, 1. This is where it lands. Third point, this one is 2, 3. So when it moves 90 degrees, this is 2, 3. This is where it lands. So rotating triangle A 90 degrees anti-clockwise about the origin lands exactly on this point. This is 90-degree anti-clockwise rotation. Another example, A onto D, 90 degrees anti-clockwise, and about 4 comma 3. So this is my center x4y3, and I'm going to rotate triangle A 90 degrees anti-clockwise. So if I just connect these two, this is going to land at this point. Then if we just connect these, I can see that it is a perfect diagonal. So a perfect diagonal and of equal length would land here. And if I follow the previous method we were doing, this is going to be 2 1. So when it moves anti-clockwise, this would be vertical and horizontal like 2 1. So it comes at the same point. Third one is 1 2. So when it moves 90 degrees, this comes here and goes there. 1 2 1 2. This is the third point. So you just remove this and connect the dots. This is triangle D, which is a rotation of 90-degree anti-clockwise about 4 comma 3. Is it working?
So yeah. So in the exam, this is a very short question. So this would be like 1 mark questions, 2 mark questions.
Yes.
Okay. And like this would be to do these like pretty fast and accurate. Like we would need a lot of practice on it, right?
Yeah, but do try tracing paper as well.
Okay.
Like, for example, like just place the tracing paper over there like this, and on the tracing paper we just draw a, and then you place the needle right here wherever the center is given, and don't let that needle move. Now you just grip the page from one side slightly and rotate it 90 degrees. So this blue would just land on this triangle.
Okay.
We'll solve the sheet once we do all 4 of the transformations. So next is fully describe the rotation that maps triangle ABC onto A dash, B dash, C dash in each case. So first of all, when I look at this question from ABC to ABC dash, I'm getting the rotation, the direction that it is clockwise. And I can see that AB was horizontal, now AB is vertical. So that's a 90 degree, 90 degree clockwise. So it is 90 degrees clockwise about A. Describe fully the rotation. Okay. And in second case, what is the angle? What do you think?
180.
180, yes. If ever you get confused about like it is 180, 170 or anything, you can connect the two corresponding points, that is B, B dash. And if that's a straight line, it is obviously going to be 180. So that's a 180 degree rotation about, this is not labeled. In most of the cases, it would be labeled and we can mention the coordinates. So about the given center. What about C part?
90.
That's 90 degree. Clockwise or anti-clockwise?
Anti-clockwise.
This is from A to A dash. So if I just connect A and then A dash, so from A to A dash,
Oh, so it would be clockwise.
applying your skills. Nick wants to rearrange the furniture in his living room. He drew this scale diagram showing the original layout of the room. Is it possible for him to rotate all the furniture through 0, 0 by the following amount and still have it fit into the room. Okay, let's check. So it is 90-degree clockwise. So let's see about 0, comma 0, 90-degree clockwise. I'm just looking at chair 1. So if I'm checking the extreme corner, this is 90-degree, that is 5 boxes. So if we rotate this clockwise, this is going to come over this position. And that's pretty much obvious that the chair would look like this. That is chair 1. Do you agree?
Yep.
We don't need to check the coffee table because the condition is if the amounts if they fit into the room. Coffee table is just going to rotate about the origin, and yes, we are sure that it would be within the room. So we just need to check the extreme points. So chair 1 is yes, coffee table is yes. We are doing this for part A. Now chair 2. So I'm looking at the extreme point. This is my extreme point. And I see that this is going to be 5 left and 3 down. So when once it rotates 90 degree, that's 5 up and 3 left. So this is my extreme corner again. Yes, chair 2 would be there. Now look at the TV. Look at the TV. So if I just connect with this middle dot, because the requirement is not to draw, it is just to check. So this is 6 units away. So when we'll turn this 90 degrees clockwise, 6 unit is out of the box. So and still have it fit into the room? No. TV is a no. Couch is a yes. Couch will go here. Yes, that is 6 units away. You move it 90 degrees clockwise, it would fit. This is 5 units away. 5 units away, chairs would fit. Coffee table would fit, but the TV will go out. So the first option is a no. He cannot rotate the entire room 90 degrees clockwise. Let's check 90 anti-clockwise. This is 5 unit away. It could fit. Coffee table would rotate. This is 6 units away. It could fit anti-clockwise. The TV would land at this position. Now this couch is 6 units away. Once it rotates, it is going to be out of the room. So that's a no again for the couch. Any confusion?
No.
Now 180 degrees, just the opposite side. So this is 5 units to left of origin. This is going to be 5 units to right of origin. Chairs is a yes. Chairs would land here. Coffee table would land on this position, 180-degree rotation. TV is 6 units away. So on the opposite side, 6 units away. Couch is 6 units away. So 180-degree rotation, the couch would be in this position.
So it all fits. So yeah.
It will all fit. And see closely, one box gap was on this side. Now that gap is on the other side. Like that is 180-degree rotation. Do not confuse it with reflection. Don't just draw it over here, okay? So the last one
Okay.
is yes. Translation is a pretty easy concept. Translation is we just pull, drag, and leave it at another point without changing the sign, without changing the orientation, without rotation, doing nothing. So whatever is there, I'm just pulling it to right, that is translation, or I'm just pulling it downwards, that is translation, or we pull it at an angle, that is translation. So no direction changes, no sign changes, it is just being pulled from one point to another point, just dragged from one point to another point, and is represented by a translation vector in which x is written first always and then y. right side is positive x, upwards is positive y. Left side is negative x, downwards is negative y. So if I just look at this red triangle, and from that T is moved to position 1, I am looking at this vertex and the corresponding vertex. I can see that there is 1, 2, 3, 4, 5, 6, 7 units to right. So that is 7, 0 because there's no movement in y. So if we look at position 2, these are the corresponding vertices. So that is 1, 2, 3, 4. This is moving 0 in x direction and it is moving 4 in y direction. Third one again is horizontal. Fourth is just vertical. Let's talk about 5. So if I just look at 5, we always count x first. Never ever like mix up the coordinates. These are not the corresponding coordinates. We always select corresponding coordinates first. So this and this. So we count x first. This is from 4 to 4 to 11. That is 7 units. And then from 1 to -7, that's 8 units. These are 7 units, these are 8, and x is positive and y is going down, so that's -7 comma -8. That is the translation vector. Or if you can also understand it this way, that if someone is standing at position A and you want them to go at position B, so you can just tell them that walk 7, you can just tell them 7 minus 8. So they'll walk 7 units in positive x direction and then they'll walk 8 units in negative y direction. So that is translation vector. Properties of translation. Translation moves the entire object in same distance. Every point moves through same distance. They are represented as column vectors x first, then y. Translation of an entire object can be named or specified by translation undergone by any point. No part of the figure is invariant this time because if there is x or y, any value, it is moving. Invariant pause which stays over there. So reflection could have invariant, rotation could have invariant points, enlargement could have invariant point. The object and image are congruent. They are always same in size. In rotation, they are congruent. In translation, they are congruent. In reflection, they are congruent. In enlargement, if the scale factor is 1, that is basically no enlargement. So enlargement is changing. We won't say that is congruent. Number 1, draw sketches to illustrate the following translations. A square is translated 6 centimeters to left. So I'll just draw a square and then move it 6 centimeters to left. And make sure that this red line would be 6 centimeters and not this green. This is 6 centimeters, right? Because these two are the corresponding points. If you just put this distance to 6, that is not 6 centimeters left translation.
Yeah, because it's moving, so the point would be on in front.
Yeah. A triangle is translated 5 centimeters to right. Same way, we just draw a triangle somewhere and mark one point for our reference and move it 5 units to right. Question number 2. Write the column vector to describe translation from A to B and from A to C. So A to B, what is the translation vector? I'll zoom in so counting is easy.
Six.
And in y direction,
Sorry?
that's x. And what will you label for y?
For y direction would be 0, right? Because it
This.
didn't move.
So you're saying xy is equal to what?
X is equal to 6 and Y is equal to 0.
Now, if that's 1 mark, this is how it will be graded.
Out of 0?
Yeah, because
Because
that's
0 to the...
not 6.
Sorry?
That is not 6.
But I selected the 2 points that were like the one in the beginning of A and then...
There is -6.
Oh, because... Oh, okay.
Now, A to C, XY. A to C. Still counting?
I'm trying to see it. So Y is 3 and X is -1.
A to C. This A to C. Corresponding points first. If you're talking about this point, this is the other corresponding point, not this. Because if I move these points 1, 2, 3, 4, this is where they're going to land. 1, 2, 3, 4. 1 is moving to this position, 2 is moving to this position, 3 is moving to this position, 4 is moving to this position. That is translation.
Okay, so
So if we just mark these 2 points, this is 3, 6.
X is 3 and then Y is 6.
Yes.
Okay.
Or we can mark these points 3, 6. These two are not corresponding points.
Okay.
B part. A to B.
So X is at 0 and Y is at 7.
Yeah, -7.
-7.
A to C.
X is at 6 and Y is at 1.
-6, 1.
So if it's going to the right, it's minus.
To left.
To the
The
left,
question is A to C.
oh, A to C. So it's okay. So to the left, it's minus.
Yeah. A to B.
X is 0 and Y is 8.
1, 2, 3, 4, 5.
But, oh wait, so, oh wait, I was doing the wrong points. I was doing the bottom point with the top point for
Yeah,
B.
yeah,
Okay.
you need to recognize those points. This is just a drag. If these are the 2 points, now A to C.
Y 3 and then X 6.
Yes, 6 minus 3. If someone would write minus 3, 6, that's wrong.
Yep.
Always X first and then Y.
Yeah, I was just listening in my head. So Y equals to 3 and then, okay, so minus 3.
These are also like 1 mark questions. Copy the diagram onto squared paper. Translate the triangle ABC. Number 1. 3 units to right and 2 units down. So that's 3 minus 2. So what are we going to do? I'm counting from A. 3, 1, 2, 3, and 2 units down. This is A. Then from C, 1, 2, 3, 1, 2. Then from B, 1, 2, 3, 1, 2. So this is 3 units to right and 2 units down. That's A part. And then B part is 3 units to left and 2 units down. So B is like 1, 2, 3, 1, 2. So if I just know this B, I know A is 2 units above that and C is to 3 units of right of it. So this is a translation of 3 units left minus 3 and 2 units down. This. So that's B part. C says 3 units upwards and 1 unit to left. So 1, 2, 3 up and 1 left. Counting from B, 1, 2, 3 and 1 left. Counting from C, 1, 2, 3 and 1 left. So that was 3 units upwards and 1 left. So minus 1, 3. This is C part. D part is 3 units downwards and 4 units right. 1, 2, 3, 4. 1, 2, 3. From C, 1, 2, 3, 4. 1, 2, 3. This is D part. Size doesn't change. The angle doesn't rotate. It is just dragged from one position to another position. On a squared paper, draw XY and mark the points 3, 5, 2, 1 and minus 1, 4. Okay, let's just assume that this is a squared paper. Or let me bring in some squares. Can you see these blue lines?
Very faintly, but yes.
Mm, Is it better?
Yep.
Okay. So let's just assume that this is my y-axis and that's the x-axis. So point A is x3, y5. So 1, 2, 3, 1, 2, 3, 4, 5. That's my point A. B is x2, y1, x2, y1. And C is x minus 1, y4, 1, 2, 3, 4. This is A, B, C. And what is he asking for? He says draw A dash, B dash, C dash, an image of ABC under the translation of x2, y minus 3. So x positive 2, 1 2, and y minus 3 1 2 3. This is where a dash would be. So again 2 1 2 3, that's b dash. 2 1 2 3, that's c dash. And if we ask for coordinate, that's a marked grid. We can also tell that. Draw a dash b dash c dash, the image of a b c under translation x4 y1. So same original x4 1 2 3 4 and y1. C 1 2 3 4 and y1. B 1 2 3 4 and y1. So that's A double dash, C double dash, and B double dash. Triangle XYZ with this, and this is transformed to y dash, x dash, y dash, z dash by translation of this. Determine the coordinates of this, and this. Okay, now there are two ways. One is exactly this way, as we did. If I just talk about C and C dash, so we can just see and like read from the paper what is it. But do you think if x is already given, that is 3 1, and you apply translation of 4 minus 2, that would mean whatever the point is, you move 4 units to right and minus 2 units below.
Yeah.
So I'm just adding the translation vector and you can get the results. So that would be 7 and minus 1 in this case. If this is x3 and y1 already, so when we add 4 units to right, so from 3, this is 4, 5, 6, 7. That becomes x7, and y is already 1, and minus 2 will make it minus 1. Minus 2 is minus 1. So 7 minus 1. We can just add those 2 points and give the exact answer. Point y is already 2, 6, and when we move it with the translation vector 4 minus 2, y dash would become 6, 4. Same goes for z. Z dash will be minus 1 minus 5 plus 4 minus 2. This gives me 3 minus 7. Any confusion?
No. We just because it's just adding and subtracting.
Yes. Number 6. A rectangle MNOP with vertices these 4 is transformed by translation minus 3 2 to produce m dash n dash o dash p dash. Represent this translation accurately on a set of x's. So give the coordinate vertices of the image. Okay. So accurate drawing. Let's do it. Okay. X1, Y6. 1, 2, 3, 4, 5, 6. M N is X5, Y6. 1, 2, 3, 4, 5, 6. That's N. And 5, comma 3. 1, 2, 3, 4, 5. 1, 2, 3. That is O, 5, 3. And P is X1, 1, 2, 3. 1, comma 3. That's P. The demand of question was to represent this translation accurately on set of x's, or else we could have done it without these x's by just adding minus 3 2 to every coordinate. So we are moving this x minus 3 and y2. So if I just move this m 1 2 3 minus 3, and y is positive 2, so 1 2, this is positive 2. I know this is M dash. I know N is four boxes to right of it, so I just go four boxes to right of it, and that's my N dash. I know O is 3 units below that point. 3 units below that point is O dash. And here we go for P dash, and we can tell all the coordinates because it is on the grid. So I can tell that M is -2 in 1, 2, 3, 4, 5, 6, 7, 8. This is -2, 8. That's 3 unit below. X stays same. -2, 5. That is 4 units to right. So that's 2 and Y stays same. And this is again X2 and Y is 5. So new answer is this. Or else this was M N O P. M was 1 6. N is 5 6. O is 5 3. P is 1 3. And the translation vector -3 2. So when we add the translation vector -3 2 to each of these, I'm just writing it this way: 1 6 5 6 5 3 1 3 1 2 3 4 coordinates. So -3 2, -3 2, -3 2, -3 2. We could have done it either way. The demand of question was to draw it. So 1 minus 3 is -2, 6 and 2 is 8. Second is 5 minus 3 is 2, 6 and 2, 8. Third is 5 minus 3 is 2, and 6 and 2 is, that was 5, 3. This is not 6, this is 3. And 3 and 2 is 5. And last one, 1 minus 3 is -2, and 3 plus 2 is 5. So see, -2 8, then we have 2 8, then we have 2 5, and the last one is -2 5. Either way, we'll get the same coordinates. We draw them, or we do it by just simple addition and subtraction. So this was translation and rotation and reflection till now. Let's try a few questions from this sheet, and we'll start enlargement in next class. We're just going to answer all the questions other than enlargement. The diagram below shows three triangles PQR. Triangle T is the image of triangle P under enlargement. Okay, I'm ignoring that enlargement part. Describe fully the single transformation that maps triangle P onto Q. P onto Q. What do you think it is?
Should be 90, right?
That should be 90, and it is rotation. So P onto Q is rotation 90 degrees. And what is it? Direction is
It is
clockwise.
clockwise.
P onto Q is
Oh no, anti-clockwise.
anti-clockwise. And what would be the center? How
It would be x equals to 1. No, yeah.
this point?
Yeah,
If
the
that's
line.
center, this is closer and this is far away. This cannot be. How we used to find the center was we join two corresponding points and then draw the perpendicular bisector. Another corresponding point, perpendicular bisector. This is the center. So
Okay.
You will be able to judge it once you start doing it.
Yeah.
The center is going to be this point. As you can see, this is 4 2. See, this is 4 2 again. And this one is 4 4. See, this is 4 4. So the center in this case is origin. You can foresee once you get some practice. Other than that, this is the method that I'm going to match these two, join these two corresponding points. And luckily, I can see that the exact mid is at 4. This is 4 boxes to right and left. And then I'll join other two corresponding points and draw the arcs on either side. And then this. So where they intersect is the center. So I'll say it is a rotation of 90-degree anti-clockwise about 0, comma 0. What is between Q and R?
Q and R.
Yeah.
It's a translation, right?
If that's a translation, 90 degrees should stay where it
Oh
is.
wait, yeah. It's like it's flipped. So it's 180 degrees because it's straight.
If it would have been 180, let's say this is the center, this goes on that side. This would appear like this.
So it's a
Out,
reflection.
that's a reflection.
And it's a reflection on it would be on the x-axis.
On the x-axis, equation is always preferred. So we would say y is equals to 0. X-axis is y equals to 0 and
Yeah.
y-axis is x equal to 0. Okay. It says triangle A is mapped onto triangle C, A onto C by rotation. Center is the origin through 90-degree anti-clockwise. So this is my center. And then when I'm rotating triangle A, may I just say that this first point is going to land at this position?
Yeah.
And this second point, can you tell me the coordinates where it would land?
Negative 2, 0.
That's right. I'm clearing up these points. And the third one, this is going to land.
It would be at negative 2, 2.
Very good. Question complete. Let's see. What is the relation between A and B?
Well, it's a rotation of 90 degrees on
A and
at
B.
point 0, 0. Oh,
And
A to B, A to B. So A to B is a reflection
yes,
that's on point. It's not the x-axis.
these are three boxes away from each other.
So it'd be at 1.5. So one box and a half. So yeah,
So the equation would be y is equals to
negative
negative
0.5.
0.5. This A to C is no more in the syllabus. That's a stretch. Okay. A to B.
And also for two, like the two eyes, it said matrix. We don't have to find that, right?
Which one?
No, for the question that we were doing right like before, it says write
Yeah,
down the
yeah,
matrix.
I actually need to check if that's in your syllabus or not. And
Okay.
even if that is, we'll be doing it once we complete all four transformations.
Okay, because from what I know, that's an A level. Yeah, A level topic, right?
Now I'll check it because there are two type of matrices.
Yeah.
One is a complete chapter of matrices. This is just a small concept.
Okay.
What is this? A to B.
Translation, right?
That's right. And translation vector is
So 4 down and down is Y. So, and then, so 2, so X is 2, and then Y is -4.
that's right. Okay, the question says -4 3 translation. Just tell me for any one point of your choice. This is -4 3 translation.
It would be at -2 4, 1 point.
X -2 Y 4. Yeah,
And afterwards, one other point could be at -1 5,
very good.
and then it would be at 1 4.
That's right. Okay. Maybe you've counted all three of them, and
I just did it from the original shape.
yeah,
So
that's
I
right.
just knew
That's right.
there's distance between them.
That's right. If you did this first one, just see that you don't have to do it for each of them. -4 3, -4 3, -4 3. You can, what you can do is just another option. You've done the first point, and you know that the second one is one
Yeah,
box
that's what yeah,
on the diagonal,
yeah.
and that's three boxes to right. That's a different approach. Let's try one rotation on this grid. Let's say the center is this point. So if I rotate this first point, this is three boxes right above that. So it is going to be three boxes to right of it. Sorry, I didn't define that. Was 90-degree clockwise about -2 comma 0. So that's my first point. If I look at my second point, this is how it's connected. 2 2. So after rotation of 90-degree, this would be 2 2, and this is where it lands. Do you agree?
Yeah, at 90 degrees.
And the third point is 2 3. So when I rotate this 2 3, this will be like this. That's the third point. So I am getting my triangle like this, 90 degrees clockwise about this center. let's see some theory first and then practice. When a shape is enlarged, it is made bigger. In an enlargement, the length of the side of the object are multiplied by the scale factor to form the image. The sizes of the angles do not change during an enlargement. As as we read, just look at this diagram as well. For example, A is being enlarged and the new image is B. So the angles, the size of angle will not change. This is just an example. If you just take a picture of a building, the size, the height, the length would change, but the angle would remain same. If there is a window, they are at 90-degree angle with each other. Angles would remain same, only the size will change. The scale factor can be a whole number or a fraction. To find the scale factor, we need image length over original length. So if the image is like 3 times larger, the scale factor is 3. If the image is smaller, the scale factor is definitely a fraction less than 1. An angle won't change. And this is one of the example. And it entirely depends where the center is. For example, if you could imagine a wall and you're holding a torch, it would cast a light in circular shape. If you take this torch away from the wall, the size will increase. If you bring it closer, the size will decrease. So the center position would matter. What do we have in enlargement? There are 4 things. One is center of enlargement. Second is the object. Third is the scale factor. And fourth is the image. For the current image, I can see that the scale factor is 2. How can I judge that? I'm looking at the object at any one side and I see that these are 2 boxes and these are 4. So they just doubled. Or I can see that this was 1 box and it doubled. So the scale factor is actually 2. Let me just go to the
What was the
writing.
second point? So it was first of all, it's the center of enlargement, and then it was
I'll repeat all 4.
okay.
Enlargement 1 is center. Second is the object. Third is the scale factor. And fourth is the final image. For example, this is my Cartesian plane, x and y axis, and this is the placed image, and this is my center. Now, just like we casted light, a ray passes from this point, touches this at extended, second line, and extended, third line, and extended. Now, when I'm talking about the green line, and let's say I'm saying that we are about to enlarge it with a scale factor of +2. So from the center, I'm measuring this distance. On the grid, it is very easy. We can count boxes. Even if you're doing it on a plain page, I can just place the needle of the compass at the center and pencil at the one vertex of the triangle. Then place the needle again here and mark. So this is 2, scale factor 2. Same way, I'll see that this is 1 and this is 2. Same with third point, this is 1 length, this is second length. We are counting it from the center. So I can now see that the new image is enlarged image with a scale factor 2. If I would just name it for ease, A, B, C, this is A dash, B dash, and C dash. So see AB, whatever the length of AB was, A dash, B dash is now twice of that. So center of enlargement, then we have object, then we should know what is the scale factor, in this case 2, and then we'll get the image. For example, we just go for extension. If the question was to draw 3 times. So starting again from the center, E dash, E dash, E double dash, and then B, B dash, B double dash, and then I have C, C dash, and C double dash. So now this would
So we just basically make when we put the compass on the center and then we draw it out and then we double the length of one of the
Yes.
sides.
Yes.
Okay.
The middle one would have scale factor 2. This one would have scale factor 3. Have you ever experienced different sizes of photocopy, like double
Yes.
sized, half sized? It is exactly the same way. So
Okay.
the photocopier would just adjust the scale factor and draw the enlargement according to that, print the enlargement according to that. The properties of enlargement. When we read this, just keep these images in mind. The center of enlargement can be anywhere inside the object, and I had it in mind that we draw two different, and I'm just trying to make a replica. For example, this was roughly at this point. Okay, I'm just trying to change the center only. Now see, center was somewhere one box away, but now I'm going to change it, and I'm taking it away. So first line, and then the second line, and then the third line. That would be much easier and neat when done with on paper and scale. Now see, it's again scale factor 2. This much length, and again I'm measuring this much length. And second one, this is 2 boxes away and 2 boxes away. And the third one, this is in diagonal 3 boxes away and 3 boxes away. So that would definitely keep the size same because I've kept these two same and scale factor 2, but it would change the position because position of center is being changed. I could have made the center at this point, and this is how we go about that. And we just join with the center and extend. We join with the center and extend. So that's one, that will be two. That's one, that will be two. That's one, that will be two. And this is enlarged by scale factor 2 with this new center. Let
How
me
do we
see.
determine the center? Or
It will
is
be
it gonna be it'll be given?
it will be given.
Okay.
Out of these four things, this when they ask about the center, this is how the question would appear. It will say that find the center and the scale factor both. See, the
Okay.
images are already given. Scale factor is pretty much obvious. I can see the all the lengths are being doubled. This is one box, these are 2 boxes. Scale factor and how we are going to determine where the center is. I'm just going to connect these two corresponding points with this scale and extend the line, and then any other two. And so this would be my center. So four things again back: center, object, image, and scale factor.
Okay,
Questions are
so
vice versa. Something is
so
given,
we base
something else.
yeah. So we basically connect the points like A and A dash and then it all leads to a point and then that's the center
Yes.
where they intersect. Okay.
So the center of the enlargement can be anywhere inside the object or outside the object or on the vertex. I just did it outside. We'll practice more.
Okay.
Let's just it was outside. Now let's just keep it within the on any one vertex of the object. Let's say the shape this time is a square, and label it A, B, C, D. And A is the center. Center is given, that's A, and scale factor, let that be 2. So when I start from A, I'm extending B, so that's doubled. Extending D, that's doubled. Extending C, and that's doubled. I'm actually counting the boxes. And this is B dash, this is C dash, this is D dash. Any issue in locating B dash, C dash, D dash?
No, because it's just four more than it. So
Yes. So with this factor of 2, this is being enlarged about the center A. So in this case, we can also say that A was invariant point that never moved. And then we definitely, if you remember, A1 over A2 is equals to L1 over L2 whole square. Similar figures. If anyone would ask you about the area, so area is actually 4 times because that's a squared relation. We'll talk about these three. If area is A, this area would be 4A and this area would be 9A because that's a squared relation. When it doubled, 2 square is 4. When it tripled, 3 square is 9.
I see.
And if you would wish to just plug in these triangles, you can actually count that yes, there are 9 of these triangles. See, this is 1, 2, 3, 4, 5, 6, 7, 8, and that's 9. That was just a proof, not required. We can simply use the formula A1 by A2 equals L1 over L2 whole square.
So
And see it.
A1
Yeah, yeah.
over A2 equals L1 over L2 squared.
Yes. In case of similar triangles, similar shapes,
Okay, and that gives us the area.
that is just area. Because we're not doing enlargement for 3D figures.
Okay.
Okay. A scale factor greater than 1 enlarges the object, and a scale factor smaller than 1 reduces the size. Let's do smaller than 1. Let's use the same figure, and I say the new scale factor is 1 by 2. So the original object was ABCD. Now, would you agree with this new shape?
Yep, it has to get smaller.
It gets smaller. An object and its image are similar, not congruent. Obviously, the size is changing with sides in the ratio 1:k, where k is the scale factor, angle and orientation of the objects are invariant, they're not changing. See these two object and image, angle stays same, the orientation stays same, it is not rotating.
Yes.
Few worked examples. Now, just imagine that if I just take this O upwards, this image will move downwards. If I take this O away, this image will become a bit thin or more away if I have to keep the scale factor same. But luckily, they just ask us to draw it once on one question. Worked example, the figure shows the quadrilateral ABCD and its image. So object is already there, image is already there. Under the enlargement, find the center. So we just connect A and A dash, and we connect D and D dash, and this is the center. No need to connect all 4 points. The book has done for all 4 points. We need only 2. They would definitely pass through 1 point. And it says find the center, done, enlargement and scale factor. And if this was on grid, I would have counted the boxes. If it's not there, I would use my scale and measure this length and then measure this length. So D dash C dash length divided by DC length, and I'll have my scale factor. In this case, that's 2. Draw the image of the rectangle ABCD with O as the center of enlargement and scale factor of 2. Center is given, object is given, scale factor is given. We just need the image. So I'm connecting O with A and extending the line. Connecting O with B. Okay, let's do the marking before connecting with other points. So see OA, this length. I repeat this length again. So that is my A dash. Then we connect O with B, and OB is 1, and then another, that's B dash. Connecting O with C, extending it. This is 1 times length. This is second time length. Connecting O with D. O to D is 1 time length, and this is second time length. So we just connect the second points, and we get the image. Center was given, object was given, scale factor was given, and we got the image. Any confusion?
No.
Worked example, let's use that as a question. Draw a triangle A dash, B dash, C dash, D dash, the image of ABCD and an enlargement of scale factor 1 by 3 through the origin. So center is the origin. Are those blue dots visible? Squares, blue lines.
Yeah, they're visible.
The grid is visible. Okay, so that's 1 by 3, and origin is the center. Just excuse the wavy lines due to limitations of this tab. We'll be having perfect straight lines when we do this in example. Okay. Now this is 1 by 3. Can you see that green line?
Yeah, I
Connect
can.
with me. So see this. So I have to divide this with 3. Either I'll measure OP with scale and then divide by 3 and mark the new point.
We do that for each one.
We'll do that for each one.
Okay.
And I'm just looking at this, and there are other ways as well. If you would just observe that the horizontal length is actually 9 boxes, which is pretty much easy to
Yes.
divide in 3 parts.
Yes.
And the vertical length is 6. So basically, that's 2 and 3. So 3, 2. This is at x3, y2 for sure.
Okay.
With
So
this
that's
method, we can actually do it without drawing lines as well. I'll just remove the line for C and show you. C, for C, it is 18 on X. This is 18 length, and that's 6. So if I just have to divide it by 3, this is it. 6, 6, 6, and 2, 2, 2. Would you agree to this?
yes.
So this is 6 units on horizontal and 2 units on vertical. So 6 on horizontal and 2 on vertical. This is confirmed C dash. So we can either count the boxes or draw the diagonals or use the scale, anything you feel comfortable depending on the diagram and requirement. D point is 21 against 9. 21, comma 9. Try this. Let me know where should I mark D dash. Are you working on this?
Yeah. 7 comma 3.
Perfect. This is 7 and 3. Last one. A is 12, comma 15. Where will we mark this?
Four comma 3.
Very good. 4, comma. That's 4, comma 5 actually.
Oh, sorry. 4 comma 5.
So that's A dash. And hence enlargement with a scale factor of 1 by 5. See, straight lines, either use compass or use scale or count the boxes or divide the lengths or use coordinates. Everything is allowed. For each enlargement, give the coordinates of the center of enlargement and scale factor of the enlargement. Just write it and missed the point. For each enlargement, give the coordinate of center and scale factor. So we need center and scale factor. Now again, if you could imagine, this is going to be very easy with the scale because that would be perfect intersection where we actually need it. This is wavy lines. This is definitely not it. For now, I'll be counting the boxes. In exam, this is the best method. Just use your scale and straight lines. You would be able to see where it intersects. That would be your center. And for enlargement, I can see this length and this length, like center to C and C to C dash. So we can see that this is 1 unit and this is 2 units. The scale factor is 2. So for now, I'm just counting the boxes, relying on boxes. See, if I have to travel from C to C dash, may I say this is x3 y minus 2 or
Yes.
B to B dash, like let me do this one first. X3 y2 minus 2, and I'm doing that again. X3 y minus 2. That brings me exactly at this point. Now I'm trying with B. That's x2 and y 1, 2, 3, 4, 5, and it's not that. Doing it again. That is midway. X1 1.5, 1, 2, 3, 4, 5. 1.5 and 5, 0.5, 1, and 1, 2, 3, 4, 5. So it is intersecting at the exact same location. And this is the center, which is
Eight
x8,
zero
5, and scale factor in this case is 2.
2. Okay.
Okay, try scale factor without the center for this diagram, without working for center. Come on, that's easy. You can see the size of the image and object.
Oh yeah, so I could just count the boxes. So it's 6 on one box and 3, so it would be 2.
Yeah, that's 2. I was not sure in this because these were slanting lines and I was not very sure. Or else you could use the same method in both the diagrams. So scale factor is clearly 2. And again, now that's a drop of 3. 1, 2, 3, 4, 5, 6, 3, 6. So another 3 and 6, because this time I'm very sure that this is 2. I don't need to check again. I am sure that this is my, I erased it before marking. That was 3, 6, 3, 6. I'm very sure that this is my center. So
Okay.
coordinate center are x3, y minus 2. And what is the correct way to do it? Place the ruler, draw the line through A dash, then draw the line through C dash, any 2 points, and they will intersect at the center. And we can just count either this length against this or any other boxes. That will just do. Okay.
Yeah.
Now try this fully on your own in any order, any method, and let me know the scale factor and coordinates of center.
Scale factor 2.
Scale factor is 2, yes.
And then can you scroll down? Yeah. Is the scale factor 0, -5?
It is the other way.
-5, 0?
No, I mean this is the image and this is the object.
Oh,
This
okay.
actually you've connected them, so it is going the other way.
Okay.
It is converging to left and top, northwest.
So it's at -3, 4.
That's right. You've already confirmed that this is 2, and I
Yep.
find A point the easiest in this case. So that's 2, 2. So another 2, 2. So -3 and 4. And one example was remaining. We tried when the center was outside. We tried when the center is on the object. And now let's keep the center inside the object. And let's say this is our object. Try and make it straight. This is the object. So A, B, C. And my center is inside the object this time. So method stays the same. I'm going to connect A and extend. I'm going to connect B and extend. And we connect C and extend. Again, let's say scale factor is 2. So from center to A, this is one box, another box. From center to B, this is two boxes in diagonal, two boxes in diagonal, that's B dash. That's A dash. And from C, again, two boxes, this is C dash. So now we come connect A dash, B dash, and B dash, C dash. So that's the object, that's the center, that's the image with scale factor 2. If the examiner will say explain fully the transformation, we will say it is an enlargement with scale factor 2 and center coordinates, whatever it would be. Let's say for this one, I can say it is an enlargement with scale factor 2 and center -3, 4. Now this was outside, this was outside, this is outside. This appears to be somewhere inside. And see which one is object and which one is the image.
The object is the red one and the image is the orange one.
Yes. So what would you expect the scale factor to be?
The scale factor should be below 0.
Below 1.
Sorry, below 1.
Go ahead, try that. What is the scale factor?
Scale factor 1/2.
1/2, perfect. And now you have to find the center.
Zero, 0.
Good. I felt drawing the lines easier this time. This was basically, yeah, other question. Finding the center and scale factor. Now copy the axis and shape on a squared paper using the origin as center of enlargement and scale factor 3. Draw the image of each shape under the enlargement. Origin. So origin and 3. Let's do this shape first. Seems a bit easy. The center is already there and 3. Now again, if I would have scale and paper, I'll draw these lines quickly and that would be easy. Or for now, I can see that this is 2, 1 in diagonal. So another 2, 1, another 2, 1. On the other side, this is one box, 2 and 3. I'm looking at this one. This is 2, 1, 2, 3, 4, 5, 6. So that's 2, 6. Now for scale factor 3, I'm going to repeat this 3 times. Another 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. And this is just opposite to the other face. And the image would look like this under enlargement of scale factor 3 and center origin. Does that make sense?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1, 2, 3, 4, 5. Yeah, 3 times. Now we do the same with this. Center is already there. That's 3, 3, 6, and 2. So this is 3, 3, 6, and 2. Another 3, 3, 6, and 2. So this is one dot. This is in diagonal 1, 2, and 3. Now I have these two already. This is it. Now I have one of the face. Now these are 2. We can just draw 1, 2, 3, 4, 5, 6. Now these are 4. 1, 2, 3, 4. And 3 times would be 12. 5, 6, 7, 8, 9, 10, 11, 12. And this is 2. 2, 3 times is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. About the center, scale factor 3, the image is in front of us. Copy the axis and shape onto a squared paper. Draw the image of A dash, B dash, C dash under the enlargement of scale factor 2. Now is just moving more for more practice questions apart from origin. And center is given scale factor is 2. Without counting, without doing anything, can we say A would lie here? Because actually we could directly see this is 3 and that's double of 3. And
So
for
yeah,
C, it would lie at this point. B is in diagonal 2 and
so
another.
diagonal, yeah.
So C dash, B dash, and E dash. It is an enlargement of scale factor 2 about the center 2 comma 1. Try this.
Scale factor 2, and then coordinates of origin.
I don't think that's a very
So it would be negative, I mean 0, -1.
very good. Scale factor is 2 and center is 0. And trust me when I tell you this, no one would believe that you did this without using pencil. This is actually only achieved in online class. If it would have been face-to-face class, I would have been using scale and pencil.
And in the actual exam, I have to use paper and
Everything is
pencil.
allowed. It wasn't allowed earlier, but now trace and paper is also allowed.
Okay.
Actually, these changes came into being after the pandemic,
Okay.
and they are pretty much reliable methods. In the diagram, square PQR S dash is the image of PQRS under the enlargement. Find the scale factor of the enlargement and coordinates of center. Six boxes, 4 boxes. Scale factor is 6 by 4, that's 3 by 2. Scale factor is 3 by 2. And it is a perfect square aligned perfectly, so that's x 4 by 2.
But since, oh wait, no, never mind. So it's at the center, 4, 2.
Yeah, because I could see through that they are perfectly aligned with each other. Like it is one box to left, it is one box to right, so it has to be the midpoint.
Okay.
Box up, one box down. So I just went for the midpoint of a red square. Or the other way was we could connect R dash and then SS dash, and it would intersect at the center. Draw enlargement of object A, B, C, D with scale factor 1 by 4. So that's a reducing in size, and center is the origin. Center is given, scale factor is given, and we need to identify where the image will be. I just need to do 4 parts of this line. If I just try 1, 2, 3, 4. So this is C dash. Or we could just divide the x and y. This is already 4 and 8. So dividing by 4 would be 1 and 2. 1, 2, 3, 4. That's D dash. You try for B and A.
So I'm just trying to go by like the viable points to count from. So
Any way you feel comfortable.
well, I'm getting 5, but then I have to divide that by 4. So 5 divided by 4
For which one? B or A?
for B.
See, the coordinates of B are 12 and 8. That means 12 this way, 8 this way, right?
Yes.
And when we divide it by 4, 12 by 4 is 3, 8 by 4 is 2.
Oh,
Next
so
B.
3, 2. Okay.
And A is 8, 12. It is just the other way around. By 4 is 2 and 3.
2, 3.
X2, Y3. This is the image. E dash, A dash. Now we could have done this one more way. Let me just remove all this and keep only C. Now see, that's C and this is C dash. Now whatever this length is, I can see this is 1 box, 2 box, 3 box and 4 boxes. So 1 by 4 would mean 1 box. Right away this diagonal. Again 1, 2, 3, 4. Right away this diagonal. And A actually lies right above C, or like that's a square. 1, 2, 3, 4. So 1 point across this. That's D dash, that's A dash, that's B dash. So we could do it either way. You can just count and see where it would be. Further questions? Sheldon uses his computer software to enlarge and reduce pictures. He has a picture that is 10 centimeters long and 6 centimeters wide. If he enlarges it to be 16 centimeters long, okay, how wide will it be? Yeah, please.
9.6.
That is 16 by 10 and equals to x plus 6. So 29.6, yes. If Sheldon triples the width of the photograph, what will be its length? So this was 10 and 6. Tripling is actually,
80
I don't
and
need
18.
this. We actually don't need this. That's triple. So the length would also triple.
Oh, so 30 and 18.
Is it possible to enlarge the picture by increasing the length and leaving the width the same? C parts.
No, it's not because all sides have to increase when you enlarge it.
That's right.
Just the angles don't change.
That's right. Sheldon needs to reduce the picture so that the quarter of its original size. What will be the new dimension?
Length will be 2.5. Width will be 1.5.
Perfect. Question number 8. Maria has a rectangular painting which is 240 millimeters by 180 millimeters. She wants to make a reduced color copy of the painting to put into a small silver frame. Rectangular painting 240 by 180. Just sketch it. It is easier for me to understand. She wants to make a reduced color copy of the painting to put in small silver frame. The area of the frame is 18 and 13.5. What scale factor should she use to make the photocopy? Scale factor.
So it was originally 240 by 1. Oh, no, it's just a conversion from centimeters to millimeters. So it was normally 2.4 centimeters, and
Oh,
it
yeah.
was normally 24 centimeters by 18 centimeters
So this is 24 and
and
18.
18.
Now everything is in centimeters.
Yes.
So what is the scale factor?
So it's from, but one side remained. Oh, wait, no. That was just that side. So it should be 1.3.
Keep it in fraction,
Okay.
like exact form. If you're writing
12 by 9 or 4 by 3.
4 by 3,
Yeah.
do you know after doing all the effort, this is wrong?
8 by 3.
No, that's 3 by 4.
3 by 4. Oh, because it's 8 by 6, and then you can simplify it to 3 by 4.
It is reduced. The scale factor should be less than 1.
Okay. Also, your microphone is kind of glitchy.
Image
Yes.
over object. Whenever that happens, please let me know. That was on charging. That always
Okay.
happens. It is always image over object. So in this case, image is lesser in size. It is reducing. So the scale factor is 3 by 4. How many
Okay.
times smaller is the area of the picture? There are two ways. We have the dimensions. We can find the area and then divide, or just square this. 9 by 16. So 16 divided by 9, it is 1.7 times smaller. Because area of smaller is 9 and area of larger is 16. Next subtopic, vectors. Some quantities are best described in giving both magnitude and direction. For example, wind speed is 35 from southeast or an acceleration upwards 2 meters per second. Like if you would just tell someone that I'm driving a car at 60 kilometers per hour, and if you
Yeah.
just ask them that 60 kilometers per hour towards north, so magnitude and direction both.
So you have to specify both.
Yeah. And if both of them are there, they are known as vector quantities.
Okay.
And scalars have only magnitudes. Other quantities such as time, temperature, speed, mass, area can be described by only giving their magnitudes. And direction is not needed.
Vector quantities can be both positive and negative, right? And then
Yes.
scalar can just be positive.
Scalar could be anything. They are not dependent on positive and negative. For example, the temperature is negative 16 degrees Celsius.
Oh, but if it's by like the absolute value, but then what about speed?
Yeah,
Can it
that's
be
why I'm
negative?
saying for these two, in order to differentiate in these two, we'll just check for magnitude and direction, and for
Okay.
magnitude only, and not about the sign,
Okay.
because there are exceptions. But in magnitude and direction, no exception.
Okay.
Vector notation. They are usually denoted by bold letters highlighted, just as this. For example, if I would write that the vector A, I need to make it bold, or I can write the vector A. You see this sign below that symbol? For ease, you can
The
put on top
yeah,
of it.
that's just like an arrow, right? Just shows
Yeah.
direction.
You can put the dash on top of it as well. So vectors are basically written different.
Okay.
So you see, if it is typed in regular writing and font, it is just highlighted with something that's a vector. That's not a normal letter A. And this is written in bold, and this is the third way to represent it. One, two, three.
Okay.
From A to B. Now, writing vectors as number pair, vector can also be written as column vector. We've already covered this in translation. For example, PQ, we can write that PQ is equals to 2, 4. The first number is X, the second number is Y, always. Worked example. Express R, S, and L, M as column vectors. Can you do that? RS.
So RS, because we just take the X and the Y, right?
Yes. And always X first.
So 4, 8.
RS is 3, 4.
Oh, and then LM is 2, 3.
No.
Negative 2, 3. 3, negative 2.
Yes. Always X first.
Okay.
Draw the column vectors. These were already drawn and we mentioned. And this is given 1, 3. So we could have started it anywhere. He started it from 1, comma 2. 1, 3 could be if I started from here. This is X1, Y3, and this is 1, 3.
Okay.
Same way, minus 2, 4. If I just started from here, X minus 2 is to left, y minus 4 is downwards. So that is minus 2, 4. Using vectors to describe a translation. As covered earlier, if it is translating from A to A dash, B to B dash, C to C dash, so we could just read and tell them that A dash is 2, 3. It is a translation with vector 2, 3. No change in size, no change in orientation. It is just dragged along the vector 2, 3. Square R is to be translated to square S. Find the column vector for the translation. What is the column vector which translates R to S?
2 by 3.
Correct. Be very careful when you choose the corresponding corners. Practice exercise writing the column vector for each of the vectors shown in the diagram. For A, it is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So A is 4, 6. I'll do A with one more method. If you could see, this is the end point and this is the starting point. We can do that end point minus start point. Coordinates of end point are 5, 15, and coordinates of start point are 1, 9. 5 minus 1 is 4, 15 minus 9 is 6. Any objection? That's what
No.
we've been doing. We counted this 4, we counted this 6. So
Yeah.
15 minus 9 is also 6. And 5 minus 1 is also 4.
So it's just like a longer way to do it.
Sometimes the diagram will not be there, but the coordinates would be given. So this
Oh,
is
okay.
the other way.
Okay.
For example, if I just tell you that coordinates of B are 5, 7 and coordinates of A are 1, 2, and I ask you AB. So from A to B, that's going to be the second point minus the first point. 5, 7 minus 1, 2. And we also call it position vector. So 5 minus 1 is 4. 7 minus 2 is 5. And if it was drawn, I could have counted from 1 to 5 is 4 and from 2 to 7 is 5. So 4, 5, either way, different methods. Tell me the column vector for B.
Do I do it that way or the other way?
Anyway, no restrictions.
4 by 2. So 4, 2.
Correct. Now, if we'll write like this, that's wrong, okay?
Yeah.
Try D, doctor.
-4, 2.
Correct. H, horse.
4, -2.
Correct. Now it says represent these vectors on squared paper. That's easy and it rarely comes in exam, but we'll do few. Let's say AB. Now start point is not specified. I can start it from anywhere, but I need to know that this is x5 and y2. So if I start from origin, that's x5, y2. This is AB. If I do mn and this is my starting point, I can see that's -2 and -4. -2, 1, 2, 3, 4. That is mn. I would write A here, B here, M here, and N here. Is it clear?
Yes.
Look at question number 3. In the diagram, A, B, C, D is a parallelogram. Write column vector for the following. A, B, C, D. Okay. So A, B is 1, 2, 3, 4, x0. Sorry, x4, y0. And DC, without reading, I'm writing 4, 0. Because that's a parallelogram and they're equal. Same way, B, C, and AD is 1, 3. What can you say about these two pair of vectors? I can say that they are equal. When we use the word equal vectors, means the direction and magnitude are both equal.
And their direction and magnitude is equal.
C was saying BC and AD. If we would have said BC and DA, that would have been different. Because BC is this way and DA is this way. But he just said BC and AD, the length and direction both were same. In the diagram below, shape A, B, C, D, E, and F are mapped onto this. By translation, find the column vector and translation for the translation in each case. So in the first one, I'll choose these 2 points, and this is x4, y2. Try B part.
B part, right?
Yeah.
Five one. I mean 5 -1.
Correct. C part.
6 -1.
Correct. D part.
-3. 0 -3.
Very good. E part.
-2 1.
Not 1 and not -2.
Oh wait, yeah. I connected
These
the
two
wrong
are not
points. Yeah. 1 2 3. So -4 3.
correct. F part.
5 2.
Very good. No, equal vectors. I just said equal vectors at that point. I could have also said like parallel The word parallel could be used and equal could be used. Equal was necessary to use because the length was also same. So equal vectors in this case, if I would just say, okay, you tell me AB is equal to which vector?
AB is equal to LM.
LM, that's correct. Any other?
It's also equal to XY.
XY. So in this
Wait,
case,
all of them, right?
yes, because all of them are 1, 2. Multiplying a vector by scalar. Now that's very easy. If you have a vector already, let's say this is A. So what would be 2A? That's 1, that's 2. So this is 2A. If I say this is B, what would be 2B? That's 1, that's 2, that's 2B. So multiplying, if AC was already 2, 1, so multiply with 2, that becomes 4, 2. AB into 2 is AC. So this was AB was 2, 1. Now this is 4, 2. That just doubles when you multiply by 2. If force F is needed to move a block of 1 kg, then 2F would be needed to move a block of 2 kg. Represented by K, whatever it would be, like twice or thrice or anything. So X and Y would just multiply. For example, A is given, then 2A is this. We multiply all the elements with 2. Worked example, U is given and 1 by 4 U is to be found. So we just divide all the elements X and Y by 4. No need to show the working in that depth. If U is equals to 8 minus 4, so U by 4 is just 1 by 4, 8 minus 4, and that's 2 minus 1. V is given, find minus 5V. Now the sign is important because V was x minus 3 y2. This was V. Now that's minus 5V. It would be 1, 2, 3, 4, 5. See, it is still parallel to that and 5 times the length, but the direction is opposite because of that negative sign. That was minus 3, 2. Now this is plus 15 minus 10. 5 times in the opposite direction. Calculate this. We can just skip this question. It is just multiplying 3 and minus 7 with the given scale factor, with the given scalar multiple. Applying skills. The diagram shows a rectangular metal burglar bar. Each section of the burglar bar can be represented by a vector. Section can also be compared in terms of vectors. So for AJ is equals to 3 times AD. Now AJ, can you see this is A and this is J, which is actually 3 times AD. AJ is 3 times AD. Would you agree?
Yes. Because there's 3 of AD
Can
in
you hear
AJ.
me? Okay. Yes. Try the first part. DF is equals to how much JK?
DF and JK.
Yep. They're written horizontally.
I can't find JK.
Let me show you those letters. This is written horizontally. ABC,
Mm-hmm.
DEF, GHI, JKL, and then MNOPQR.
Oh, okay. So it'll be 1/2.
So DF is 1/2 of. No, that will be 2.
Oh, because JK is smaller.
Yes. So JQ and JF, that's JQ, and this is JF.
So that would be 2, 3, 4.
Yes, 1 by 4, okay? Because JQ is 1/4 of JF. This time JQ is smaller.
Okay.
C part HPHF. When the starting point is same, it is easy to identify. HP, I think blue would be more visible, and HF.
So because HP is smaller, then it should be 1/2, right?
Correct. 2 times GO. Let me find G, EF, G. This is G and this is O. 2 times GO is equals to how many times of GC?
So that's 2.
If I just write GO and I write
Because
GC,
GO 2 times would be up to GE, and then GE is how much of GC?
I just write that
Oh,
half of GC is 2 times U.
oh, because it's smaller, right? Oh,
Yep.
okay.
Next one, 3 times DG. This is DG is equals to how much CL?
1.
No, that's like 3 DG. This is 3 DG.
Yeah, and then isn't that 1 CL?
Oh yes, right. 1 CL.
And then
I
6 PE.
just made a mistake of counting this 1, 2, and 1, 2, 3, 4. I just
Yeah.
counted the boxes. I would have counted the lengths.
And then PE.
BE 6 times is equal to how many CL?
2.
Correct. Okay. Again, now the column vectors are already given. We just need to substitute. If A is this, so minus 2A would be multiplying with minus 2, so that's 2, 8.
2, 8. Yeah. So I
And
had a question for add maths.
yeah, sure.
So it's for this school because they don't know I'm taking extra classes and stuff. They assigned like a tutor for me for add maths, and that tutor basically he said that I need to have like a solid understanding of advanced functions. But is that true for the add maths?
Yeah, if we compare these two subjects in AdMath, functions are advanced
Okay.
compared.
And then he also said calculus as well.
Yes,
So
he's right.
okay, so both of them.
Yes.
Okay. Okay.
Those are like around chapter 13, 14, 15, 16 for
Yeah.
calculus.
Yeah.
Okay. I think that would be it. That's another subtopic. As far as
And
addition of vectors is concerned, when we are solving them algebraically, that's not an issue. Like if I say AB plus BC, AB plus BC, you just have to plug in 3, 1, and then BC is minus 2, 2, and we can just simply add them. So that's 1 and 3.
we have vectors in add maths too, right?
Yes, that would
But
be again a little in depth.
hmm, okay.
But definitely, this is going to help over there.
Yeah.
By doing this, you can say that you've already covered 60% of AdMath, whichever chapter is repeating itself. Logs would be new, differentiation would be new, integration would be new.
Okay.
Whenever column vector form is given, that is easy task. We just have to add them algebraically. And other than that, in case of diagram, suppose this is AB, BC, and AC separately given. AB is 3, 1. See, this is x3, y1. Then BC is minus 2 and 2. So x minus 2, y2. And then AC is x1, y3. So you know that AB plus BC is AC. Now just look at the diagram, AB plus BC. So this is my start point and that's my end point. Vector AB took me from 1 comma 1 to 4 comma 2. And then BC took me from 4 to 2, 4. So which is basically the resultant of AB plus BC is AC, start to end. Subtraction of vectors, it actually stays the same, only the direction reverses. For example, in this case, if the examiner would have said AB minus BC, so AB would stay like that. This is A, that's B. Now plus BC, if that's in this direction, minus BC would be in opposite direction. And this would have been our resultant.
So just go in
Or-
the opposite direction.
Yes, because of the negative sign. And they figure the various line segments represent vectors. Find in the figure directed line segment equal to the following. Now I'm looking at the diagram and the question. AE plus EC. Even if I do not look at that, this is somehow telling me that from point A to point E, and then it says from point E to point C, wherever it may be, wherever it may be. So it is actually taking me from A to E and then from E to C. So I can say the resultant is AC. Basically, E is the common point. So even if we do not look at the diagram, we will be able to solve most of these. Let me just hide that and let's try. Now see if the diagram is not there. I can say that E is the common point. It took us from A to E, then E to C. So that's only AC. Then B is again common. I can say that's DE. Now AD plus DB is actually AB. Then AB plus BC is AC. Fourth one. B is common, then E is common, then A is common. So that will be CD. Does that make sense?
So we take out whatever is common.
Yes. If
Okay.
I just write like RS plus SQ, that is obvious that the vector is taking us from R to S, whatever direction is, and then from S to Q. So the resultant is basically RQ.
RQ.
This is the
Okay.
common. Now we're just going to look at the diagrams. Sometimes we may have different letters representing them. The first one is AE plus EC. So this is AE plus EC. So this was my start point, that was my end point. So basically AC. Second question says DB from D to B and then from B to E is basically DE. Third question says AD, A to D, then D to B is basically plus BC. Now that this is start, this is end. So from start to end is AC. CB plus BE plus EA plus AD. So C to B plus BE plus EA plus AD. So see, that's start, that's end. The resultant is C to D. It started from C and ended at E. So resultant of these four vectors is CD. Another worked example in form of column vectors. A is given, B is given, we just plug and solve them. A plus B, vector A is written, vector B is written, 3 plus 2 is 5, 4 minus 1 is 3. And in case when we just write like A plus 4B, this 4 is known as scalar multiple. Now A is 3, 4 and B is 2 minus 1. So 3, 4 plus 4 2 times is 8 minus 4, and finally 8 plus 3 is 11 and 0. So A plus 4B is 11, 0. Another worked example, OACB. This is OACB. Is a parallelogram in which OA is equals to A, OB is equals to B, M is the midpoint of BC, and N is the midpoint of AC. So if those are midpoints, I'm just marking these lines for myself so I won't have to go back to the description. Find in terms of A and B OM. So we start from O and end at M. May I write that OM could be OB plus BM? That is the path. Now I'm going to
Yes.
fill in some values. Vector OB is actually B and BM is half of A. I cannot write them in bold again and again, so I'm using the symbol A dash. And then second part says MN.
I
M,
don't understand the second part. So it's B plus half of A?
yeah, BC is A, so BM is half of A because that was the midpoint. OA is A, right?
Mm-hmm.
And this is a parallelogram, so BC is also A. Properties of parallelogram. Opposite sides are parallel to each other and equal in length. So if I say PQRS, so if I say PQ is A, SR would also be A. And if SP is B, RQ will be B.
Yeah. But
So
then it's
BM is half of BC and BC is A.
the BC is half of BM, yes. And then 1/2 of 8.
COM is OB plus BM. OB is clearly B
Yes.
and BM is actually half of BC.
Yes.
And BC was A. Would you agree BC is equals to OA?
Yeah, it does. Because it's opposites.
Yeah, that's where this is coming from.
But why is A 1/2?
Can you tell me what is this complete length?
A.
A. So if I just mark something in midpoint and let me label it X, what would be OX?
Half of X.
Half of A.
Oh, so the midpoint is X. Okay. So half
So
of
if
A.
this length is A, and M is the midpoint. So what would be BM?
Then the midpoint is A. That should be A.
The full length is A, so half length would be
Half of A.
half of A. That's what half of A is coming from.
Oh, okay.
Second part, MN. May I
Yep.
write MN as MC plus CN?
It leads
Now,
up to it. Yes.
MC is half of A. And what would be CN?
Cn is then half of B.
Half of B, but in opposite direction. So I will be writing negative half of B. Because B is upwards and Cn is downwards.
Negative half of B. Okay.
Negative B. So you could simplify it to 1 by 2 A minus B. Show that OM plus MN is equal to AN plus ON.
Both equal to ON.
Okay. So we have to show this OM plus MN. OM plus MN is basically ON, and it says OA plus AN is again AN. Why do we show this? That is pretty much obvious. Okay, in form of vectors. So let's find it. OM plus MN. Now OM, we've already done it in previous part. May I just copy it? B plus 1 by 2A. And then MN, already done in previous part, is half A minus half B. So that is now A plus half B. And second part of the question, OA plus AN. Now looking at the diagram, OA is straightforward A and AN is half of B. So these are equal, shown. Any doubt?
No.
Okay. Practice exercise. P and Q given express in column vector form 3P. So simple substitution, 3 into 4 minus 2. So the answer is 12 minus 6. P plus Q. P is 4 minus 2. O minus 2, and Q is minus 1 minus 3. So when you add them, minus 3 minus 5. Given that A is this, B is this, express 2A minus B as a vector. Try this.
12, -7.
Negative 7, 12. Yes. 8 and 4, 12. And negative 7, yes. For question 3, the question is just same. A, B, and C. Simple substitution. Let's just try E, G, and H. Question 3. E part is A minus 2, B minus C. So A is already 8, 10 minus 2, B minus C. I think that would be easy if I write 2B minus 2C. 2B is 4 minus 2, and minus into minus is plus, and C is 0 minus 1. So that's 8, 10 minus 4 minus 4, 0 minus 2. 8 minus 4 is 4. 10 plus 4, 14, minus 2 is 12. 3E. Try G part.
10, 9.
10, 9, yes. And let's try H part as well.
Wait, sorry. I'm a bit confused about E still.
Okay. For E, I actually multiplied 2 inside and got it as A minus 2B plus 2C.
Okay.
And if you want to do it as it is, we'll compare the final answer. A was 8, 10, then minus 2 stays outside. B is 4 minus 2, and C is 0 minus 1. So 8, 10, the minus 2 is outside till we deal whatever is inside. 4 minus 0 is still 4, minus 1, minus minus plus minus 1. So 8, 10, And minus 2 into 4 is, oh, I got 4 2 times 8. That was 8. And 8 minus 8 is 0. So 4 to is minus 8 and plus 2. So getting 0 and 12.
Okay, so
Okay.
you just did both of them. You
Yeah.
just extended the brackets. Okay.
H part. C is 0 minus 1. B is 4 minus 2. And A is 8 10. 0 minus 1. 1 by 2 stays there. 4 minus 8 is minus 4 minus 12. 0 minus 1. Half of that is minus 2 minus 6. This is minus 2 minus 7.
Minus 2's -7.
Yeah. Number 4. In the diagram, BCE and ACD are straight lines. AB is equals to 2A. While I'm reading this, I'm looking at the diagram. And BC is equals to 3B. The point C divides AD in ratio 2 ratio 3. So this is 2, this is 1. And divides BE in ratio 3 ratio 1. That's 3 1. Expressed in terms of A and B, the vectors AC. I'm looking at AC. Is AC equal to AB plus BC?
Yeah.
So that would be 2A plus 3B. Try CD.
CE plus ED.
Okay. When you're looking at CD and you're trying CE plus ED, remember CE and ED both are unknown. So we won't be using this. But we can use this statement that the point C divides AD in this ratio. So I already have AC. You can see that 2 and 1 in blue.
Yes.
So CD is already half of AC. Half of AC. So that's 1 half of 2A plus 3B. We can leave it here. We can multiply the 2 inside. That would be A plus 3 by 2B. Clear? AC, we have AC and CD is, that's a straight line. ACD is a straight line. And we know that AC ratio CD is 2 ratio 1.
AC ratio 2D, right? It's 2 to 1.
Yeah.
And then we already have A, and then C is half of A.
CD is half of AC.
Okay, and then we just do half of what we got for AC. Okay.
Yes. Now looking at CE, whatever is BC, that is one third of BC. BC ratio CE. So CE is actually 1 by 3 of 3B. So that would be just B. Any doubt?
No.
Now ED. ED is EC plus CD. That is EC plus CD. And the direction matters in vectors. Previous part was CE, this is EC. So I'm substituting negative B, and CD is A plus 3 by 2 of B. And simplifying both of these, A stays there and 1 by 2B. Clear?
Yes.
And triangle XYZ. XY is X, YZ is Y, and WZ is 1 by 4 of XZ. WZ is 1 by 4 of this full. That means this side is 1, this side is 3. Any objection in this ratio? And any doubt in this one?
XY. Yeah, XY equals to X, and YZ is Y, and then WZ is 1/4 XZ.
Yeah, this part is 1/4 of this full.
Okay,
So if I extract that one out for myself,
that's
I'm
3.
left with 3.
Okay.
And these diagrams are never drawn to scale. Like they may look like 1:2, but they may be written as 1:3. Just in this case, BC is 3 times of CE, but that's not the case when we look at it. These are not drawn to scale.
Okay.
So we follow the algebraic information that's given. Now, first part is finding x, z. So from x to z, that's xy plus yz, and I'm following that path where I know the vectors. Xz is xy plus yz, and xy is just x, and yz is just y. So x plus y. Now xw. May I write xw is 3 by 4 of xz?
Yes.
So that will be 3 by 4 of x plus y. Last is yw. So for yw, yx plus xw. So yx is minus x, and xw is already in the previous part. 3 by 4 of x, 3 by 4 of y. 1 minus 3 by 4 is 1 by 4, 3 by 4 minus 1 is negative 1 by 4x plus 3 by 4y. That's yw. Clear?
Yes.
Try question number 6. Is the first part done?
Yes.
What is it? AB.
I got 2p plus 2q.
There's a mistake. See, I'm moving from A to O. That's minus 2p plus 2q.
Oh. Oh, because I went the other way, but that still be negative. Okay. And then b part is 2p plus q. Yeah, b part is also done. But I'm just gonna quickly see if it's negative or positive.
Yep.
No, it's positive. Okay, so I got 2p plus q.
Correct. And MN.
So that's p plus q, but negative p plus q.
Positive P and negative Q.
Oh, is it?
See, this is half of this. So that, and this is half of 2q. So that's q, but that is in opposite direction. So we say minus q.
Okay.
Okay, magnitude of vector. This is basically Pythagoras theorem. So if I have this x3 and y minus 4, wherever it starts, we move 3 units in x, we move minus 4 units in y. So magnitude, this length would be Pythagoras theorem. 3 square plus minus 4 square whole square root, and the length will be 5. So the magnitude of vector is its length and is denoted by the symbol or the symbol modulus sign on either side is used to write the magnitude of the vector AB. You use Pythagoras theorem to calculate the magnitude of vector in general. So if it is already given 3 minus 4, we just substitute the values x square plus y square whole square root. That would be equal to magnitude in this case, which is 5. So magnitude of A is equals to x square plus y square whole square root. So 5 square is 25, 12 square is 144, 144 plus 25 is 159, and that's 13. Getting it?
Yes.
Position vector. It is from the origin. If we have like, if this is B, so OB will be x4, y4. If I have C, OC will be x1, y4. From the origin, position from the origin is known as position vector. So OA is given x3, y2. That's the position vector, and we can find the magnitude of OA as well. That is 3 square plus 2 square whole square root. Worked example. The position vector of A is 3, 2, and the position vector of B is minus 4, 2, as given in the diagram. Find the vector 2 times AB. So, first of all, I need to know what AB is. Now, AB is AO plus OB. Remember, whenever you have in this form, we can represent them in terms of position vector, which
Yeah.
is always second alphabet minus the first alphabet.
Yes.
It is always this, because we are starting from A, we are ending at B. So when you start from A, we go AO, that is actually negative OA, and then we go OB straight to reach B. So the first one is always negative. For example, if XY was given, the first one will be negative. If we have PQ, we'll write OQ minus OP. So in this case, it says 2 times AB. So 2 times AB would be 2 times OB minus OA, and then OB is minus 2, 4, and OA is 3, 2. So that's 2 into minus 5, 2. That's minus 10, 4. Times AB is minus 10, 4. If point A is minus 1, minus 2B is this, find the magnitude of AB. Try this. Are you doing it?
Yes.
I hope you remember the formulas.
Did I answer in square root form or decimal?
Yeah, that would be in decimals. What are you getting?
5.6.
I'm getting
5.7. 5.7.
I'm getting 9.2. See, A is given, B is given, and magnitude is basically Pythagoras theorem. So distance AB is x2 minus x1 whole squared plus y2 minus y1 whole square root. So minus 1 minus 5 squared minus 2 minus 6 squared. Change in x is 6 and change in y is 8. So that's 10.
I was actually adding them. I was adding x2 and the next one.
We need the difference.
Okay.
6 square plus 8 square is 100 and square root that's 10.
Okay.
Practice exercise 23.8. Calculate the magnitude of each of the vector correct to two decimal places. So when we have perfect vertical or horizontal, we don't need to apply the formula. If I look at vector R, which is part F, so this is 1, 2, 3, 4, 5. So that's just 5. No need to apply any formula. When we look at vector A, that is 4, 1. So A would be 4 square plus 1 square whole square root is square root 17. B part is AB, which is 2, 3. So that's square root 2 square plus 3 square. 3 square is 9, 13. So square root 13. Try C part.
Square root 18.
Correct. 3 square plus 3 square whole square root is square root 18, which simplifies to 3 square root 2 if we are not going in decimals. Question number 2. Find the magnitude of following vectors giving answers to two decimal places. And this question also demanded that I didn't read it first. So question number 2 is find the magnitude of vectors giving answer to two decimal places. So A is 5 square plus 9 square whole square root. And I'm getting 10.30. I was getting 10.295. So up to two decimal places that rounded to 10.30. And Mn is 7 square plus 11 square whole square root is 13.04. Try the last two.
C is 5.
Correct.
D is 10.
Correct. Question number three. O is the point 0, comma 0, P is 3, comma 4, and Q is minus 512, and R is minus 815. Find the values of O, P, O, Q, O, R. So basically, P is already there. So from O to P will be actually 3 and 4 because that's 0 only. So I'm applying this directly. 3 square plus 4 square whole square root is 5. OQ 5 square plus 12 square whole square root is, I guess, 13. This is 5 square plus 12 square. Yeah, that's 13. Try OR.
18.8.
No, I'm getting an integer. That is 8 and 15.
Oh, 17.
Yes. Point A, B, and C have position vectors OA, OB, OC. Write down the coordinates of A, B, and C. A is 4, comma 2. B is minus 1, comma 3. And C is 6, comma minus 2. B part says write down the vectors AB, CB, AC. So when I'm looking at AB, I'll be writing OB minus OA. Any doubt?
AB, OB, O minus OA.
Yeah, OB minus OA. This way.
Because we just take out the difference. I mean, like the common, the O.
Yeah, this formula will get off the directions and everything. See, for AB we did OB minus OA. That is the second one minus the first one. Then OY minus OX. Then OQ minus OP. Second one minus the first one. It takes care of the direction as well. If you're confused, we can discuss this again. See if this is AB, the first one. That is AO plus OB. From the
Yes.
diagram, that is AO plus OB. But in the question, only position vectors are given, which is OA, OB, OC, OD, OX. So if I just turn that around, I will be forced to write negative OA. AO is whatever, AO is actually negative OA. Here, AO and negative OA. Now we do one more step just to rearrange. That is OB minus OA. So this will happen always.
So wait, so
Yep.
it equals to AO. So it equals to negative AO, and that's AO.
OA and AO are not equal. OA is not equal to AO. OA is equal to negative AO. or negative OA is equals to AO.
So in what we did AB equals to AO plus OB.
Yes, let me write that again slowly. AB, you dictate please. AB is
AO and then OB.
AO and then OB. Now this is what we were to find, and OB is given, OB is given, and OA is given, not AO. So if I just change this AO into OA, that would be negative OA because I'm changing the direction, and the negative mark will handle that. And then the last step, just rearranging, writing the positive one first and then the negative one. It is always second letter minus the first letter. If I would draw it here, like let's say this is P and this is Q. So when we have to find PQ, and this is OP, this is OQ. I'm going to write it first and then explain. Second letter minus the first letter. Now we go through the book. PQ is actually PO plus OQ. PO plus OQ. But position vectors are OA, OB, OC, OD, right from the origin, not from P. So if I just switch this direction, I can write negative sign because I'm reversing the direction. OP plus OQ. And simple rearranging, OQ minus OP. These two are same.
OQ and negative OP are the same?
No, I've just rearranged them. I've written this first and then this.
Oh yeah, yeah. And then okay.
So if it is XY, we will be writing OY minus OX. And if it is GH, we'll write OH minus OG. If it is PK, we'll write OK minus OP. So for AB, that was just OB minus OA. And we substituted the values because we had value for OA, or else I would have to change these values if I will write AO. So we just take care of it before substituting the values. So this is 1 minus 4 minus 5 and 3 minus 2 is 1. Then it says CB. So CB. Please dictate what should I write?
OC minus OB.
OB minus OC. We write the first letter first and negative sign comes with the first letter. The second letter first and negative comes with C. Second, first letter is with negative sign. First is with negative sign. First is with negative sign. So C is with negative sign. Now I substitute the values. OB is -130 and OC is 6 minus 2 -7 5. Try AC.
OC minus OA.
Correct. And OC is 6 minus 2 and OA is 4 2. 6 minus 4 is 2, minus 2 minus 2 is -4. Now, OATB is a parallelogram. MN and P are midpoints of this. It would be easy if we draw them. So question number 5 is OATB is a parallelogram. So let's say O is the origin. O A T B. There is a grid, so I'll draw it more neat. O A T B. OATB is parallelogram. MNNP are midpoints of BT, AT, and MN. This is P. I'm just going to confirm. OATB is parallelogram. M, N, and P are midpoints of BT. BT we have M, and AT we have N, and MN we have P, respectively. O is the origin, and the position vectors of A and B are A and B. So OA, position vector of A is A, position vector of B is B. Find in terms of A or B MT. So the first one, MT. May I write it as half A?
MT?
Yep.
Yes, that's half of 8.
Yep. B, T was A. So this was halfway between that. So that's half A. Now T and starting from T, moving towards N as again halfway, but that is in opposite direction. So negative half of B. C part M N. Mn would be MT plus Tn. Mn is, we've just done it. So MT is 1 by 2 of A and Tn is negative half of B. Either we leave it like that or just take out 1 by 2 as common. D part says the position vector of P, giving our answer in simplest form. So position vector means OP. I'm doing it here so I don't have to move up. OP is OB plus BM, or let's just do it half of MN. Yeah, that would be the later part. Plus MP. So OP is OB plus BM plus MP. OB is just B, BM is half of A, and MP is half of MN. So half of MN is already there. Half of MN would be half of A minus half of B. So that's B plus half A plus 1 by 4 of A minus 1 by 4 of B. So simplifying fully, 1 by 2 plus this is 3 by 4 of A plus 1 minus 1 divided by 4 is 3 by 4 again. 3 by 4 of B. So 3 by 4 A plus B. Clear?
So we just plug in the values that we got from before, and
Yes.
then we simplify it.
Yes.
Okay.
Find the magnitude of the vector joining the points this and this. So that is again distance formula. Magnitude of vector joining these two. So x2 minus x1 whole square, y2 minus y1 whole square, square root. So that's minus x square minus 8 squared, and that's 10. Try B part.
So first it would be -2 minus -1. No, -2 minus 3,
Yes.
and 6 minus -1.
Yes.
Square root 74.
Correct. Okay. Applying your skills. Vector B shows the velocity in kilometers per hour of a car on a highway. The side of each square on the grid represents speed of 20 kilometers per hour. Find the speed at which the car is traveling. Can you understand what the question is saying?
So B is the velocity, and the sides are all 20 kilometers. So we just have to find what B is to get the speed that the car was traveling.
Yeah. So that's 20, 20, 20, and 24 times that is 80. And 1, 2, 3, that is 60. So 80 square plus 60 square whole square root is 100. No. Yeah. 8 and 6 gave us 10. So 80 and 60 is giving me 100 kilometers per hour. Try question 8.
6.71.
That was 1, 2, 3, 4, 5, 6, 6 and 3. 6 square plus 3 square whole square root is 6.71, correct? Number 9. In the diagram, OA is equals to A, OB is equals to B, also AC is equals to 2A, not to scale. Okay, I just saw that. That was too much out of the actual site. So AC is 2A. I'm just going to write it here that this is 2A. And then AD is equals to 3B minus A. AD is 3B minus A. Write AB in terms of A and B. AB. AB. If I do not look at the diagram, may I write OB minus OA if I'm not looking at the diagram?
Yeah.
Now we just fill in. OB from the question was B and OA from the question was A. Now you may look at the diagram to clear your concept. See, AB, this has to go in reverse. That is why we're substituting negative sign there. Okay, B minus A. And second part says OD equals n times B, where n is a whole number. OD is n times B. OD is n times B, where n is whole number. Now let's find OD. Give it a try, then I'll be with you.
So this is just basically OB plus BD.
Yeah, it
But
could
then,
be plus BD, but BD is unknown.
yeah.
So try a different path. You were doing OB plus BD, but this
So
is
can I
unknown.
do OA plus AD?
Yes.
And that would be A plus 3B minus A. So that could just be 3B.
Yes. That is A and that is 3B minus A, simple substitution. So 3B. And what's given? OD equals NB. Therefore, N is equals to 3. Clear?
Yes.
C part. Prove that OAB, ODC. OAB, ODC. Prove that OAB and ODC are similar triangles. Okay. OAB and ODC. Okay, are similar triangles. We've just done that OD is 3B. So this section is actually 2B. And now we have to prove that this smaller triangle, let me use some shadings. This one in red and the other full larger triangle. OAB and ODC are similar. So one thing we can say about them is common angle at O, like AOB angle is equal to DOC common angle. I'm actually going for side angle side. Now when I look at OB, that is B, and OD is 3B. On the other side, when I look at OA, that's A, and when I look at OC, that's 3A. So basically sides are 3 times. And I already know what AB is, I'm going for CD as well. So CD is COD minus OC. And OD is already 3B and OC is already 3A. So 3B minus A. Now I can also say that even if I ignore the common angle, this is one side, this is second side and third side. AB is equals to B minus A and CD is equals to 3 times B minus A.
3 times 3 minus 8 is 1.
Therefore, we can say ODC is 3 times, or simply the ratio of sides is equal. We can say OB over OD, OA over OC, AB over CD. That's B over 3B, that's A over 3A, that's B minus A over 3 times B minus A. So all are 1 by 3, 1 by 3, 1 by 3. The ratio of sides are equal, hence proved that they are similar triangles. Any confusion?
No.
Okay. One question is remaining in your free time to try that. And we've actually covered this last topic as well. If you get time, do have a look at the next exercise. This is just mixture of the topics we've already done. If there will be any problem, we'll discuss it together.
Okay. Or add.
Okay, we have further transformations. Worked example. A reflect shape A in line y is equals to x. So y is equals to x. We would first just sketch the line. It passes from 0, 0, 1, 1, 2, 2, 3, 3. And in line y is equals to x, points would just swap. If I see this first point, which is x2, y1, 2, comma 1, it will become 1, comma 2. So x1 and y2. And we can also see that it is same distance across the line of reflection on the other side. If I just look at this point, this is one box away. We look at this point, that is one full diagonal and one half. So one half and one full on the other side. And this is one full, one half, one half, one full. So we just keep getting a shape. This point is x minus 1, y 5. It will become this is 5 minus 1. This will become minus 1, 5. And so we get a shape. Reflection in y is equals to x. And the worked example, sketch triangle A with vertices 1, 1, 5, 1, 5, 4. So x1, y1, x5, y1, x5, y4. Rotate the shape 180 degrees about point 5, 5. So we have center of rotation x5, y5. And when you rotate it 180, we just connect it and stretch the line, extend the line on the opposite side. We can connect this and extend on the other side. And then we can just use the compass or count the boxes to get the equal distances and see where it lies after rotation of 180 degrees. I hope you remember reflection, rotation, enlargement, and translation.
Yes.
Okay. Enlarge rectangle A, B, C, D by scale factor of -2. So positive enlargement was like this. If we have center and triangle, I'm connecting this and extending on the same side. Connecting, extending on same side. Connecting, extending on same side. And then with the 2 scale factor, whatever this distance is, and we do it 2 times, this is 2. And when it says -2, so if this was the original question and this was the center, for -2, we just extend it on the opposite side. We connect and extend. We connect and extend. Connect and extend. So now I'm going to measure this with the compass, and on the other side, this is 1, this is 2. We always count from the center. Same case 1, 2. Same case 1, 2. Shorten page. So this is it. So positive and negative scale factor, this is the only difference. So we have all the coordinates of red image A, B, C, D, red object, and about the center. So this is connected and it goes on the other side by magnifying unit 2. Combining transformations one after the other. So for example, you've already seen that an object can undergo a single transformation to map it to an image. An object can also undergo transformations. Following capital letters are conventionally used to represent different transformations. You don't actually have to remember these. It will always be given in question. M is for reflection, R is for rotation, T for translation, and E for enlargement. For shape P shown in the diagram, let T be the transformation to 1 and M be the reflection in y-axis. Draw the image P dash after transformation TMP. Now, how do we do this? We read it from right to left. Now, P is the object itself. So first we apply M. What was M? M was the reflection in y-axis. So first we reflect it in y-axis. This is 1, 2 boxes, 1, 2 boxes, and 3. And this. This is the first part. And then T. What was T? T is x2, y1. 1, 2, and 1. So x2, y1. This is going out of the page. Why so? Let me just have a quick look. Yeah, yeah. So getting this,
Mm-hmm.
now this is A part. B part says draw image P double dash, that is P dash. After transformation, P, first it is T. So first we translate x2, y1. This is 1, x2, y1. This is x2, y1. And then we reflect. Reflection in y-axis. So just change the color. Reflect in y-axis, the invariant point stays on the line of reflection. This is P double dash. Third one, what single transformation maps P onto P double dash, P single dash onto double dash. So I can see single dash is this and double dash is this. So what would map? It is a drag. If we bring it to left, that is 1, 2, 3, 4. Minus 4, 0. A translation of minus 4, 0 will map P dash onto P double dash.
Okay.
Practice exercise. For each pair of reflected shapes, give the equation of mirror line. And when I look at this first one, these green objects, I'm just imagining that I would place my pen on the paper like this, or like this somewhere, and see where it feels like this would be the reflection. So when I just place them exactly in between, definitely that is going to be the line of reflection. When I see
Probably,
these,
yeah. Probably y equals to x, right?
y is equals to
Negative x, though.
negative x, yes. Y is equal to negative x. And what about the second one?
Y is equal to x minus 1.
Perfect. Okay. I would see that these two are corresponding. So this is the midpoint. And these two are corresponding. This should be the midpoint. And this is the line.
So
Equation
y equals x plus 2.
minus x plus 2.
Oh, yeah. Minus x.
Draw each shape on the coordinate grid and perform the given rotation. Rotate ABC 90 degrees anti-clockwise. Center is this. So x minus 2, y2. This is the center. Now when it is inside the shape, I'm just going to look at ABC individually. So when I look at A, I'm imagining that it is connected by this L shape. And when I rotate it anti-clockwise 90 degree, this is where I can see A. Any objection?
No.
Same way, I'm looking at B. This is how it is connected, and anti-clockwise it comes at this position, 90 degrees. Same way C would come at this point. And this is 90 degrees anti-clockwise rotation about the given point minus 2, 2. And obviously, we do have that option of tracing people. Rotate object A, B, C, D, E, F 180 degrees about x1, y minus 1. So where would you guess the coordinates of F?
So if we were to draw, so then F would be at -2, 1, or 1, -2.
Please say that again.
Then F would be at 1, -2.
Very good. This is F dash. So E, coordinates of E, just to differentiate. The center is in red.
So E would be at -2, -2.
E is at yes. No. -1, See, E is this much far.
Oh, okay. Then
I always find it easy counting it in stairs. 1, 2, 1, and 1, 2, 1.
okay.
You may do it in any way. There's no restriction. And then D. If I just don't look at the center now, I do know ED is 3 boxes. I just bring it down here.
And then that means C is 0, -5.
C is this way. Yes. And B comes down.
2
Do we
boxes below. And A is 1 box. Yeah.
This is pretty easy on paper pencil scale because you will be having your scale here and then see just where it would lie. 2 boxes in diagonal. Draw the image of each shape under the given transformation on the same set of x's. Okay. The reflect shape A in the line y is equals to -x -2. Now this is not only reflection. This is coordinate geometry as well because you need to know where this line would lie. There are 2 ways. I can see that you have a good grip on this topic. So you can directly guess, or else just in case if the line is unpredictable, we can always use few values. And I know at x0 y is -2. And then another value, let's say I use 1. This is -3. At x1, y is -3. So we may have these coordinates x0, y2, and at x1, y is -3. Sorry, at x0 it was -2. x0, y is -2, and 1 -3. So we know this is the line. Y is equal to -x -2. And first one says reflect shape A in the line y is equal to -x -2. So that's shape A in yellow. This is right there. Now this is 4 boxes. 1, 2, 3, fourth box. Let me mark that with a dash. Second says rotate shape B 90-degree anti-clockwise about 2, 4. X2, Y4. X2, Y4. 90 degrees anti-clockwise about this point. I'm looking at the top vertex, 90 degrees would bring it here, and it is pretty easy shape because that's an isosceles triangle, and I can see one, two, three, four boxes. So just one, two, three, four boxes, and these are the two other positions, 90-degree, anti-clockwise, about the given center. Any objection?
No.
So this is P dash, and the third one, reflect shape C in the line y is equals to -3. This is y minus 3. First, we reflect it in -3. This is 1, 2, 3 boxes to right. So this would be 1, 2, 3, and 4 boxes to left. This is somehow how it should look like. And then rotate it 270 degrees clockwise about the point x minus 1, y minus 1, x minus 1, y minus 1. We're rotating it across this point, about this point, and it says 270 clockwise. Rather going 270 clockwise, we can go 90 anti-clockwise. If we just connect these anti-clockwise, this is the first point. Connecting this is 2, 3, 3, 2. I just lost my first point. Yeah, 2, 3, 1, 2, 3, 1, 2. Now I'm looking at this extreme point. This is 1, 2, 3, 4, 5, 6 boxes in 2. So 2 and 1, 2, 3, 4, 5, 6. I can just trace the shape because we know this line was moved to this position. So this is 90 degrees anti-clockwise about this, or we can say 270 clockwise about the given center. Any confusion on this?
No, it's just drawing the line and then making it simpler if it's like 270 to 90. So no.
Yeah. Copy the x's and shape onto squared paper. Draw the image of D, E, F under the enlargement with scale factor -3 and center is x2, y0. X2, y0 center is already there and scale factor is -3. Can you try that?
So D would be at 1, -1, -3.
D, 1, 1, 3. Yes.
This is enlargement, right?
Yes.
Okay. So then it would just be 6 points away from D. So yeah, we could put E.
That's nice. You just saw that this was 2, you multiplied it by 3. And I was counting this. This is 3, 1. So I just went on the other side 3 times. 1, 2, and 3, and then down 3 times.
Okay.
So
Same
that's nice.
thing for F as well. Just be
Yeah.
3 down.
1, 2, and 3.
Wait, aren't D and F? I mean, aren't E and F connected? Not D and F?
All 3 are connected. See, the shorter side is E. Oh, yeah. What did I do?
So you just have to move the F below the E.
Oh, yes. 2, 3. Thank you. Enlarge the given shape by a scale factor of -1. Now see, this is 1. That means the size won't change, but it's negative, so it has to be on the other side. Use the origin as center of enlargement. This is the center. I can see C is in diagonal, 2 boxes away. B is this way, 3 boxes away. That's B, C,
So
B, and
even if it's -1 or 1, like if it's enlargement, the shape won't change.
yeah, because the scale factor is 1.
Oh, okay.
That is 1 time. This is also, we can also call it like 180-degree rotation. Scale factor -1 enlargement would look like 180-degree rotation. Enlarge shape BEFG by scale factor -2 and center is x -1, y -1. So scale factor -2. I just connect it this way. This is 1, this is 2. And then E, this is 1, this is 2. E and G are basically opposite side. That's just a kite. So this would be G, and these are 3 boxes. The other side should be 6 boxes.
What makes it, like, which direction makes it positive or negative? So if it was normally 2, it would go backwards.
I'll show you.
Okay.
Object, image, center. This is positive. We move from center towards object and keep moving.
Yeah.
And in negative, this is center, this is object. We go in the opposite direction. So basically, in positive, we have center object image or image object center. Basically, center is on one side,
Okay.
and in negative, center is in between these two.
But in both cases, the object gets bigger.
Yeah, that depends on this number. That's twice
Okay. Okay.
because this was 1. The object is same size, but it was negative. So see, center is in between both of them. This is
Okay.
negative, center is in between. Again, negative in between. Enlarge the object shown by a scale factor of -1.5 using the point 1, 0 as the center of enlargement. X 1, y0. So q is basically the center of enlargement and scale factor is 1.5, negative 1.5. Now it has to stay in between. If it was positive, I would have extended p this side, o this side, and this side if it would have been positive, but that's negative. So what will we do? We connect it and go opposite side. We connect and go opposite side. Connect and go opposite side. That is the only difference between positive and negative. So x1 y x1 y0. This is the center. So p is just two boxes to right, so it would go three boxes to left because of 1.5. 2 into 1.5 is 3. M is three boxes upwards. 3 to 1.5 is 4.5. So 1, 2, 3, 4, and 4.5. That is M. And I can just connect these two. And now, if we see, this is P. This diagonal needs to be 1.5 times as well. If this is one box, this needs to be 1.5. And here I get O. Same way, this is one box. We go 1.5 this way. And this is enlargement scale factor negative 1.5. Question 8. Enlarge the shape by a scale factor of minus 1 by 2 using the origin as the center of enlargement. Negative 1 by 2 and center is origin. Now again negative opposite side. So this point L, this is one box away, it should be half box away. I'm looking at point M. These are 5 and 1. So that would be half and 2.5. Are you satisfied with this enlargement of point M?
Yes. Because also if it's a value below 1, then it'll get smaller.
Yes.
Okay.
Now these are two boxes, so it should be just one. This is L, this is K, this is M. Now if I look at M, these are two boxes. These should be one again. And in between, this was 1, 2, 3, 4 boxes. So in between, it should be 1 and 2 boxes. L, M, N, G, and K. This is enlargement with 1 by 2 scale factor, center 0, 0, and negative. Okay, question number 9. ABC maps onto A dash, B dash, C dash after an enlargement of scale factor 2 from the center of enlargement x to y5. This is 2, this is 5. From x to y5, that's the center. And scale factor is positive 2 and mapped onto A dash, B dash, C dash. Let's find this. It is positive, so I'm connecting the center with the point and extended in the same direction. So if that's 2, this is where I'll see C, B, and this is 1, 3, 1, 3, this is A. A dash, B dash, C dash. Would you agree to this transformation? Scale factor 2 plus 2.
Yes. So it's just multiply side. Okay.
And then it says it is then mapped onto E double dash, B double dash, C double dash by reflection in the line x is equal to 1. X is equals to 1 is basically through AB. So reflection through AB. Then we are reflecting the enlarged image. C boxes to left is here. B dash is 2 boxes to left, 1 box to left. So it goes 1 box to right at the center. Same way E goes to this point. So A double dash, B double dash, and C double dash. The first one was enlargement. The second is reflection. Draw and label these two. Done. Any doubts?
No.
Probably. Should I start? Are you getting it?
Yeah, I understand.
Is the first part done? Enlargement.
Oh, I was doing question 10.
Yeah, this is 10.
Oh, okay. I thought there was like a glitch. Okay.
A square MNOP maps onto M dash N dash O dash B dash after enlargement of scale factor 1.5 with center x3y4. x3y4 is B itself. So I'm enlarging it by 1.5. These are already 2. So 2 into 1.5 is 3. And this is how it would look. M dash N dash O dash, and this is P dash. The enlarged one is then rotated 180 degrees about x0, y6. X0, y6. So 180-degree rotation. I'm looking at M dash. This is 3, 1. This is where we'll find M double dash. And then I'm looking at N. This is 6, 1. And N dash.
Why is
So
it pushed down?
that is 180 degrees rotation. See, if I would draw this line, and it will make more sense.
Oh, okay.
And my mistake should be moving upwards. Those two downwards and these two upwards. Thank you. It is actually always a swap. For example, it looks like this, so after reflection, it would look like this.
Okay.
The point that is above it comes at the downside. So this is O double dash and P double dash. Copy the diagram and show the position of both. Done. Yeah, we can start next chapter.
Okay.
For IGCSE Ag Maths, so